Wow, Neil Armstrong. Hey, wait a minute. You're supposed to be on the moon. I just saw it on TV.
Oh, there's a tape delay, and with all solar winds.
Nobody that I know of in my field uses the so-called scientific method. In our field, it's by the seat of your pants. It's leaps of logic. It's guesswork.
You don't see the curvature of the earth. That stuff is flat.
Globusters taking over. Bye-bye, moon man and rover. NASA so mediocre. Sorry, but your ball is dead. But your ball is. Globusters taking over. Gotta ride this roller coaster. But the truth is getting closer. Sorry, but your ball is dead. But your ball is. Get the shovel for the spice hubble. Piecing up the puzzle. Need to bust your bubble. Evil gonna crumble, yeah? Sit down, be humble. Got the ball, you better fumble. You'll get mad, cause at this fight I'm about your uncle.
And then they call me the liar. I mean, it's absolutely unbelievable the pathetic techniques that they have to use to prove their heliocentric model.
Pops at the president, Jaren got the evidence. Arrow slaying Jesuits and Zach Sharkum is evident. Dead to earth electric and it's resonant. Your residence is heavens and I hope you settle in like some sediment. If we so wrong, why they lying to discredit it? That's not too intelligent. That's a guy, not an in court, but we ain't really in the settlement. It's time to awaken from the pseudoscience sedatives.
Globusters taking over. Bye-bye, moon man and rover. NASA so mediocre. Sorry, but your ball is dead. But your ball is. Globusters taking over. Gotta ride this roller coaster. But the truth is getting closer. Sorry, but your ball is dead. But your ball is.
Inner World Productions.
We accept the reality of the world with which we're presented. It's as simple as that.
And welcome everybody to Globusters, another Sunday. Welcome to the show. We're going to do things a little different today. We got a very cool debate for you. Sunday debate live. We've got Austin, Caleb, and Derek going up against Globey McGlobeface, Globeman, and Blitz PhD. So welcome everybody to the show. Let's bring everybody on here and see how everybody's doing. All right. Welcome to the show, everybody. And go ahead. We'll start with Caleb. Go ahead, introduce yourself real quick, and then also tell people how it's going to be working with Super Chats, please.
Yes, sir. Caleb.fe on TikTok. I teach True Earth. Essentially, how the donations are going to go, we're going to be donating all the proceeds that are created today through Super Chats and asking questions and things like that. We're going to send our side of the proceeds to Paul from Tinfoil Hat. He creates these tinfoil hats, if you guys didn't know. He's been paralyzed from the waist down from a cancerous tumor that they found on his spine. And then if you guys, Blitz, if you want to tell who your guys' proceeds are going to, but I just want to make it extremely clear. The Super Chats that you guys send in, they need to be $10 and up if you actually want to ask a question to either side, to the Flat Earth side or the Globe Earth side. So make sure you attach a question if you want a question asked and who the question is for, and make sure that it's above $10 if you want it to be read, as well as you can donate more if you feel like helping these two guys out that really need it. So if you guys can introduce who your guys' proceeds are going to, that'd be awesome.
Yeah, so hi everybody, I'm Blitz. I'm sure stuff is linked in the description. Our proceeds are going to be going to a man named Dean. He's a regular content creator on the Globe side of TikTok. He goes by Truth by Science or True by Science on TikTok. He recently had serious jaw surgery. He had an infection, I believe, and had to have some bone grafting done. And while he was able to put a down payment, thanks to many donation campaigns in the last few weeks, he's still struggling with medical debt. So our half of the donations will be going to him.
Nice. Darren, you want to say anything else?
Excellent. No, that's about it. Unless you want to have people introduce themselves real quick, just say who you are so people know.
Yeah. Let's all do that. Let's have Austin, Derek, and Globeman and Globey do it real quick.
Austin, you go first.
Okay, I'm Austin from Wits It Gets It on YouTube. And I'm not familiar with all the TikTokers, to be honest, because I'm censored everywhere else, so I can only imagine. But yeah. So Witsit or Austin, whichever one.
Sounds good. And there you go, Derek.
Awesome, guys. I'm Derek, just as it sounds in the name. I'm on TikTok. You can find me at Derek.2. I teach the true earth, and I teach common sense about the true earth and the globe model, and I explain it in a way that you should be able to understand. And all we ask is for you to take this debate serious and see the validity of this argument.
Okay, Globe Man.
All right, what's going on? I'm Globe Man. Again, I'm also from the TikTok side along with Blitz, and yeah, I just post content trying to address flat earthers' claims. That's pretty much it. Nothing too crazy going on over there.
Okay, and Dr. Blitz.
I'm Dr. Blitz PhD, whatever. I am a TikTok content creator. I do primarily science content. I don't actually do any flat earth stuff in videos, but I do plenty of flat earth debates, moon landing debates, and so on. And I'll, introduce my credentials in my opening statement.
Excellent. And McGlobeface.
Yes, Globey is good.
Globey.
I am a TikTok creator, and I teach that the true Earth is a globe. That's it. Let's go.
Okay, sounds good. We're going to start out with 15 minutes each, and they can, organize it however they want, 5 minutes each, or 10 minutes, 2.5, whatever it's going to be. It'll be about 15 minutes to do the openers, and then after that, we can get into open discussion. And it might be a little bit contentious, but if it gets to be too crazy, then we'll go to some sort of structured, 1 minute question, 1 minute answer. Hopefully, we don't have to get there. We can just be gentlemen, but we will see how it goes. And I believe that the Globe is going first, correct?
Yes.
Okay, you can begin when you want. Are you going to be screen sharing for the opener or no?
No, I'm not screen sharing, but I believe that the others might be.
Okay.
Right. So, hi everyone. My name is Blitz. I hold a doctorate in mathematical physics. While my colleagues are going to address the claims of this debate directly, I'm going to take another approach. I'm going to show that taking the flat Earth claim seriously comes at a very high price, one that I don't think anyone should be willing to swallow. You see, by suggesting the Earth is flat, a series of positions must be taken in concordance because our knowledge of the world around us is highly intertwined. For example, a flat earther typically has to discount the existence of mass attracting mass, also known as gravity, as we all know that if gravity exists, it would pull any sufficiently large mass, like a planar Earth, into a spherical shape. This rejection of gravity means a rejection of Einstein's general relativity, of course. Note that this claim is absurd on its face because general relativity can be tested locally on Earth in laboratories. Indeed, even early experiments were able to establish a high degree of agreement between the theory and observations. In particular, even as far back as 1964, experiments were devised to measure the effects of gravitational redshift as predicted by Einstein, with results agreeing with the model at the 99% accuracy level. Rather, flat earthers often describe their account of what we might call gravity via electrostatics. While it is true that electromagnetism is stronger than gravity, the claim that electrostatics can account for the forces observed flies in the face of electromagnetism, the force that is the most well understood. Notably, neutral metals do not produce electric fields, and the neutrality of metals is easily testable with experimental apparatuses. A flat earther might also reject the rotation of the Earth, as it implies a non-planar shape. Unfortunately, in doing so, a flat earther must also reject the Sagnac effect, which can conclusively determine whether a measuring device is in an inertial reference frame or not. Of course, when one uses a laser gyroscope or similar devices to perform such a measurement, experiments detect a positive result, namely these interference patterns appear, demonstrating a non-inertial, i.e. rotating reference frame. Of course, the original results of the Sagnac effect are consistent with both the ether model and special relativity, but neither are consistent with a non-rotating planar Earth. Certainly by rejecting the Sagnac effect, they must reject special relativity. So why do I bring these up? Well, physics is not done in a vacuum, pardon the pun. Rather, physics is built upon well-trodden paths on the shoulders of giants. The audience may not know this, but the best scientific model ever developed is a model in physics known as quantum electrodynamics. And this model relies on special relativity, quantum mechanics, and classical electromagnetism. I'm happy to go into the details later, but suffice it to say, the model makes predictions that agree with measurement to roughly 1 part in a trillion. No other scientific theory even comes close to that degree of accuracy, and this prediction would be impossible without special relativity, without quantum mechanics, and without the classical understanding of electromagnetism. And yet, in order to believe flat Earth, one must believe that both mass-based gravity does not exist, and that the Earth is stationary, 2 beliefs that are incongruous with quantum electrodynamics, among many other scientific predictions which are also, but slightly less so, spectacularly accurate. But lest I be misunderstood, I'm not claiming with certainty that general relativity and quantum field theory are perfect models. Of course they're not. We drive science forward by improving our models and sometimes shifting the paradigm toward a new, better understanding of the world around us. But bear in mind, when these paradigm shifts occur, old models are not thrown out and replaced with nothing. Rather, they are replaced by new models that can make even better predictions. And if that was what my opposition presented, this discussion would not be happening on a YouTube channel, but in academic circles. But that is not what the opposition will do. They will present no alternative models with quantitative predictions, they will not do no mathematical analysis, and they will perform no rigorous scientific experiments. Only one of the sides of this argument can claim to have done all of those, and that's my side. So to my opposition and to the audience, is this a price worth paying? In order to satisfy the belief in an undemonstrated flat Earth, one has to throw out effectively all knowledge of physics we have gained in the last 150 years. This means that nuclear power, used to power millions of homes, works just by accident, not by the merging of special relativity and quantum mechanics. That electromagnets that are utilized in speakers and microphones just work by accident, not for the reasons we think from classical electromagnetism and special relativity. That our application of medical particle accelerators, which are used to treat certain cancers, just work by accident, not because we understand quantum field theory, electromagnetism, and special relativity. No, I suggest it is far more reasonable to accept the position that the Earth is a spherical ball, roughly, rotating about its axis, than to accept all of our understanding of modern physics is false and its applications are just happy accidents. With that, I'll pass it on to Globe and the Globe Base.
All right, I'm going to share my screen here. Let me know when you guys can see this.
Go ahead, you're good.
All right. So what we're looking at here is a program called Stellarium, which I think you all are familiar with at this point. It is an astronomical application that shows us where all the stars are at any time and date in the future or past. And here we're looking at, can you guys see my mouse? Probably,
Yep.
right?
Yep.
Okay, so here we're looking at Australia. We're in Australia per the red arrow. This was July of last year. That's when I did this observation live on TikTok. And here you see right here is the Southern Cross. That's the Southern Cross constellation and the 2 pointers. Now I'm pointing this out because, as you can see here, we're looking south-southwest. Now this is where the globe model tells us those stars should be at that date and time. Now, if I take this and go over to South Africa, don't change the date or time, you'll see the Southern Cross is up higher in the sky, but it's still south-southwest, between south and southwest, south-southwest.
It didn't update for me. Did it update for you guys?
Did what?
No.
It's still showing the one in Australia.
My screen shows South Africa. Hold on. How about now?
Yep.
Yeah, you're good now.
I don't know what that was about. All right, so you can see south-southwest is the Southern Cross is way up in the sky now. It's at a higher altitude above the horizon. However, and a different orientation, different angle, but it's still south-southwest. Now you can see here, I'm just in South Africa. Same date and time. We replicated this experiment. This is what I expected to see. We replicated that live on TikTok with an observer in Australia and South Africa. Now, going to Walter Bisland's model, we can see that that observer here in South Africa would have been looking south-southwest, which is right about here on flat Earth. If that's north, that's south, right? That's south-southwest. So the Southern Cross would be about here. That means at the same exact time, an observer over here was seeing the Southern Cross south-southwest, which would be about here, at the same exact time. That means the Southern Cross, and this goes for all the other stars as well, we would just happen to be looking at that one, they would have to be in two different locations at the same exact time of night. Or you're going to invoke this model which says that the stars are over here on the left, but the light is bending all the way around to the observer over here, which there's no physical method to make that happen in reality. That's almost a 90-degree, 180-degree bend of light. So we can take a look. I don't know how much time, I didn't look at the time, but
you got
this is
2.5.
How much time I got left?
2.5
Anybody
minutes.
paying attention?
2.5 minutes for you.
All right, thank you. All right, so that model
pointers.
This is the gentleman in South Africa.
There is the Southern Cross.
I don't know how well this is going to be able to be seen here.
And it's what time? What time is it by you right now?
They're the 2 pointers.
It's 7:25 p.m.
7:25 p.m. All right, so we're gonna check this.
There's the Southern Cross here. And he looks down and show you the compasses.
All right, that works. So we're gonna check this against.
Let me get to where he's showing the compass.
And
here's the compass. All right, so south-southwest was on the compass.
yeah, south-southwest.
Okay. I'm going to go through this kind of fast because of time.
And there are the pointers.
You can watch this all uncut on my page, and here's the observation from Australia. Now, take a note that the angle of the stars is the same as Stellarium was showing, as well as the height above the ground. So there's the observation from Australia. So this is just really all you need, in my opinion, as far as whether or not the Earth is flat. And this is really because this is what you're saying is happening. And all these observers looking south are seeing the same stars in different directions at the same time. When in reality, let me mute this. When in reality, the reason we see all these stars looking the same way is because the Earth is spherical, and everybody looking south from the southern hemisphere is looking indeed south. This is what you're seeing. Now tell me, does this make more sense that everybody's looking south at the same stars at the same time because they are indeed looking the same direction? Or does the flat Earth model make more sense, in which you have to replicate stars infinitely around the outside of the Earth all at the same time? Okay, I'll leave it there. Pass this over to Globe Man.
Okay, Globe Man, you got 5
All right.
5 minutes.
All right, sounds good.
Just take the share. I don't even know how to stop sharing here, Globe Man.
I think at the bottom of the screen, it should let you stop.
Stars looking south when you're south.
It also might be at the top of the screen to say
Not
stop
south.
share.
Because Earth's a
Go for it.
All right. And let's see. That bar should get out of the way here in a second. Is everyone able
you're
to see
sharing.
it?
Sorry. Yes, we see your screen.
All right, cool. I'll just mute myself and let this play, and this will serve as my opener.
Did you share with sound? I hope so.
Oh, I'm sorry, what was that?
When you share screen, you have to click the little button in the lower left that says share with sound, or else we're not going to hear it.
Oh, okay, my apologies.
Just stop sharing and then reshare.
Gotcha. Sorry, I don't use
no problem.
this app very often.
Okay.
All right, it should be good now.
Okay, go ahead.
Flat earthers make many different claims that they believe provide evidence for the flat earth, often saying things such as gas pressure requires a physical container or water can't stick to a spinning ball. Now I'm just going to go ahead and start with the claim that gas pressure requires a physical container. First of all, the formula required to find atmospheric pressure is shown here, and this formula is derived from the principle that the weight of the atmosphere above any given point exerts a force on the air molecules below. That's what gives us atmospheric pressure. The pressure decreases as altitude increases because the weight of the air above decreases with altitude. This can easily be measured using something like a barometer. And just as gravity and the globe would predict, the atmospheric pressure indeed does decrease as altitude increases. And the pressure gradient within our atmosphere also demonstrates that at no point are we going to have some kind of high pressure immediately next to a vacuum. Even in the most extreme vacuums in space, there's still some pressure. It's incredibly small, but it's still there. But what would we expect to happen if the Earth was truly in an enclosed system like flat earthers claim? So gas tends to spread out uniformly in a confined space over time due to the random motion of its constituent molecules. This is known as the principle of diffusion, which is... Sorry guys, it's freezing up. My apologies.
Sounds good from this end.
It's good on our end, by the way.
It's good here.
It is?
Yep.
Oh, sorry. Based on the idea that gas molecules are constantly in motion and tend to spread out to fill the available space. Now, what if we apply this principle to the atmosphere? Well, if the atmosphere was in a closed container, the gas pressure would eventually equalize throughout the container. The only way that you're going to be able to avoid the gas pressure equalizing is by either A, accepting gravity, which unfortunately would make the flat Earth coalesce into a ball, or B, saying that the Earth accelerates upwards at a rate of 9.8 meters per second squared. But flat earthers don't like either of those explanations, and unfortunately that means that they have no reason to explain why we observe a pressure gradient within our atmosphere. In other words, what I'm trying to say is that the only way we can explain a pressure gradient, whether it be in a container or not, would be by using gravity. But since flat earthers deny gravity and can't tell me where the 9.8 meters per second squared downwards acceleration comes from, that means that the gas pressure would equalize. Again, this is because the gas molecules are in constant motion and tend to spread out uniformly within the confined space. But allow me to reiterate, in real life what we see is that as we increase our altitude, our atmospheric pressure will decrease. Again, this is something that we can predict before we even measure it by using gravity. And gravity is something that flat earthers are going to have to deny the existence of, or else their flat earth no longer works. Another thing that flat earthers claim is that nobody has ever seen the curvature of the earth for themselves. This claim is demonstrably wrong, and I'm going to show you a few ways that you can see the curvature of the earth, even for yourself. First, we're going to start with something called a horizon dip angle. Now what the globe predicts is that as our height increases, our eye level line and the horizon will have a greater angle between them. But on a flat earth, due to linear perspective, you would expect that the horizon would always rise to eye level. So now let's go ahead and take a look at what we see in real life. Now what I'm showing here on screen was taken by someone named the Main Surveyor on YouTube. And here's another picture that was taken. Jeez. I don't know why it keeps for the other face of the theodolite. Now I'm sure I don't need to point this out, but I will just in case anyone doesn't know what they're looking at here. There is a clear dip angle that we are observing between this level line and the horizon, which is here. And luckily for us, the Main Surveyor even left a screenshot of his logbook so we can see exactly what the dip angle is. And the measured drop would be about 7 minutes and 39 seconds with a standard deviation of plus or minus 3 arc seconds. This observation was taken from an elevation of about 22 meters, and the reason we're seeing that kind of a dip angle is again because of the curvature of this big beautiful earth right here. Again, we have another observation in real life that does not match what a flat earth would predict. Another thing that flat earthers like to say is that water always finds its level. And often what I'll do to reply to this claim is mention how we have high tides and low tides happening simultaneously at different places on the earth. By definition, that means that the water is not level. And as I would hope we would all know, level just means having no part higher than another. Now an easy way to think about this is to imagine a plane flying at 30,000 feet and its altitude is staying constant. Whether the surface underneath it is curved or flat does not matter here, because again, all level is having no part higher than another. But furthermore, level is going to be determined by gravity. Now when an object is level, that means that its surface is perpendicular to the force of gravity. So obviously that means that if an object is not level, it means that its surface is at an angle to the force of gravity, and the normal force is no longer perpendicular to the object's surface. Now the reason gravity affects whether something is level or not is because it causes objects to be attracted towards the center of the earth. And when an object is at rest on a surface, such as a table or the ground, the force of gravity acting on the object is balanced by the normal force exerted by the surface. And again, like I said before, if an object is not level, it means that its surface is at an angle to the force of gravity. To make a long story short, all I'm trying to say is that flat does not equal level. And for my final point, I wanted to show that the Earth's curvature can even be seen from a plane. Now I want to start off by saying this screenshot behind me was taken from a video by Wolfie6020. And I already know what you guys are thinking. Either A, it's the window distorting it, or B, we're looking through a fisheye lens. Now first things first, we can prove that it's not the window distorting the image because this is a look through the exact same cockpit. Now looking through this window, we can see that the hangar door in front of it has remained straight, as it is in real life. So quite obviously the window is not distorting this to make it appear curved. So now we know for sure that this image here is not showing the window distorting the horizon. Now we're also lucky enough that Wolfie panned the camera up and down, so we can prove for sure that it's not a fisheye lens or a wide angle lens that's distorting the image. Now we can see even with the horizon at the very top of the frame, the curvature still has remained the same. And again, even when the horizon's at the bottom of the frame, we still have the same rate of curvature. So in conclusion, what we figured out today is that what the flat earth predicts does not match what reality has to offer. Flat earth has no consensus, flat earth has no model, Flat Earth has nothing that would be required for it to be a probable hypothesis. So now to finish, I just want to say one thing. To accept Flat Earth is to deny reality. And with the hefty price tag that carries, I'm surprised that anyone has bought it.
All right.
And that's it.
Thank you, Team Globe. Let's go to Flat Earthers here now. Let me go to over here. Who's going first? Caleb, you're on mute.
I can go first if you guys want.
Sure.
Okay, timer's up and 15 minutes. Go ahead.
Okay.
Are you sharing?
Slideshow. I might just do it from here. Yeah, I'm just gonna do it like this. I can't get it to present.
There should be a little button up in the upper right, little present button. Can't really see, it's a little small.
Nah, I'm not able to get it.
All right, just that way.
So, yeah, I'm just gonna do it like this. So the question is the Earth a spinning water ball that goes 500,000 miles an hour through space while Polaris sits in the exact same spot, or is it a level topographical plane that could possibly go on forever? We will discuss this today heavily. Let's go on to the next slide. Let's go over a few things which we shouldn't be seeing if the Earth were a ball of the dimensions and models claimed by mainstream science. Selenilian eclipses, long-distance photography, as well as expecting water to convex to its container. Our atmosphere, I can't see the, let me just move this. Our atmosphere existing next to the vacuum of space with no container, which was kindly reiterated with Globeman's introduction. Selenilian eclipses. So during a Selenilian eclipse, which is a lunar eclipse where we have to believe we're in between the sun and the moon, and the Earth's actually casting a shadow onto the moon, you can see here during some of the Selenilian eclipses, we're seeing the shadow start from the top and go to the bottom, as well as we're seeing the sun and the moon both above the horizon at the exact same time. You have to believe that this is some insane looming effect, which is casting the moon and the sun all the way up into the visual perspective of the terrestrial person on the ground. You have to believe that you're not actually seeing the moon here. You're not actually seeing the sun when you're seeing a Selenilian eclipse. These are just refracted images of the actual physical objects. Let's keep going. Long distance photography completely destroys the globe, completely just wrecks it. There's no way that anybody can say that this is just perfectly modeled on a CGI model or whatever they want to say. There is 6 miles of missing curvature between these 2 points. These peaks are at like the most, I can't remember the exact height of these 2 mountains, but I did the math before, and there's about 6 miles of missing curvature, even if you add in the elevation of both of the mountains. So, sorry, Globers, we are just seeing way too far. Keep in mind, you have to believe that this is some magical looming effect, making the Earth appear as if it's flat. You aren't actually seeing these mountains. They are being refracted perfectly to the horizon. So, this is going to come up a lot in this debate. There's going to be things said like refraction, when nobody's going to have any specificity of what kind of refraction is going on. You can invoke 7/6R, but you still have to invoke the radius of the Earth, which is assuming that we know the center of the Earth and we've only dug about 7 miles down, which is, in my mind, insane. As well as we're seeing, this is a mirage here. You guys can see in the top picture, this is what an actual mirage looks like. This is not a mirage. This is the Chicago skyline being seen from over 50 miles away, sometimes as far as people see it from 80 miles away when the sun backlights it. And you can see this picture at the bottom right here showing that it's being backlit by the sun from over 80 miles away. The tallest building in Chicago is 110 stories, Willis Tower, formerly known as the Sears Tower, which rises 1,451 feet. Again, you have to believe that refraction is just perfectly refracting these buildings as if to make it appear that the Earth is flat. Maybe refraction isn't actually refracting the skyline to the eye level. Maybe it's just the Earth is flat. So let's go on to my last one of long distance photography. Everybody should have seen this, but if you're not familiar with this, this is called the Black Swan. It is an oil rig that was seen from 9.41 miles from a 1-foot observer height, necessitating that the Earth's radius be over 200,000 miles. Again, all that the Globers have is to say refraction. When we look over long distances, refraction doesn't work to refract things up. It actually refracts things down. Hence why when I see videos from Globers or Globey specifically, he'll show videos of boats being half hidden. That's the refractive index of the atmosphere refracting the image down. It's not the physical curvature of the Earth because there is none. Water proves easily that the Earth is a level topographical plane. When fluids are static, meaning at rest, they are level at the surface. Everyone should know that. The surface of the Earth is covered 70% by water. We are supposed to believe that all of this water just convexes at the surface to the rate of 24,901 mile circumference that mainstream academia purports. Whenever we look at water, there's no terrestrial observation you can show us today to show that water bends. Water does not bend. It's completely level. It will not bend 8 inches per mile squared tangent to the observer's height, to their viewpoint. You can prove this through just natural physics. You can look at this. You can never bend this water bottle to make the surface of this water bend. Hence why, and we'll get stuff like this. We'll have Globers show like a little droplet of water, which this is actually due to electrostatics to the water. That's why it's doing this, holding this adhesion. And this is not to scale. Comparing 1 drop of water or a little bit of water in a vial is not, you can't compare that to quadrillions of gallons in the ocean. That's literally just a non sequitur. It's just a fallacy in and of itself. And then the last point that I'll make here, and then I'll pass the time on to Austin or Derek, whoever wants to go. Gas pressure, like was said in Globeman's opener, gas pressure, having gas pressure or a gradient, both. It necessitates that we have a container. You have to believe that this spinning water ball is sitting and coexisting right next to the vacuum of space, which is 10 to the negative 17 torr. This would equalize. There's nothing stopping these from equalizing. Jaron has some good thought experiments where if we were to create a vacuum the size of a room, put a shoebox in the middle of that room, have a lever that's operated by Bluetooth that opens up that shoebox with atmospheric stuff in it like oxygen, nitrogen, and other gases. If we open up that container, it's going to seek equilibrium immediately with the vacuum that's surrounding it, being the room. Why doesn't this happen with our atmosphere? This can't be explained. If it can't be demonstrated at the surface of the Earth, you cannot invoke that gravity is holding it at the troposphere, at the very top of the atmosphere next to the vacuum of space. Makes absolutely no sense. I'll concede my time to whoever wants to go next.
Eric, you got it.
All right, hold on. Let me get my screen sharing.
Hold on,
Caleb, you got to end your screen share.
There you go.
Let's see. All right. I got a couple videos in here. I'm not sure if you guys wanted the Globers want them or not, but welcome, guys. Welcome to the most controversial topic on the Earth, and it just so happens to be about the Earth. And that's what we're going to point out today. We're going to not look up to the sky as the globe people want to try to prove the ground that's beneath their feet. We are going to look at the Earth and the observations that we can make and come to the conclusion whether or not they're possible on either model or just one model or both. So essentially, the things that we're going to go over, we're going to go over that all of the photos of the Earth are fake. They're provably fake and admittedly fake by NASA. We're going to talk a lot about curvature because when we are talking about the shape of the Earth, the shape is pretty important, and the ball would make it. You would have to have curvature on a ball. So we're going to talk about the curvature and how an airplane flying over a curved object would also have to curve with that object. Globeman pointed out that level is level. No part is higher than the other. I'd like for you to just look at this globe here and tell me if no parts are higher than the other. You have to believe that they're not higher than the other because of the center of gravity. So it's all just a whole bunch of guess games and trying really hard to avoid the topics. You're going to see what we'd like to see the globe people do is prove that the Earth is in motion, prove it's a sphere, and prove that you can have an atmosphere next to a vacuum. Water does need a container. And by the end of this presentation, I hope you all know that NASA needs to be defunded because they're not doing their job. We are going to see a lot of different fallacies come out of the Globe Earthers today. They are going to get you to try to look up to prove the ground, as I've been saying. We're just going to look at the different shape balls and the shapes of the continents and where's the rest of the continents that are supposed to be in these pictures and how they're constantly changing. If the Earth were a ball, we would not have composite images. We'd have real images because we would have billion-dollar satellites flying around through space. So that's just one of the big deals. The airplanes here, if you want to look at the design of a SR-71 Blackbird that travels 2,200 miles an hour, very sleek, very aerodynamic. And then you get this space shuttle here that clearly does not look like it's going to withstand this pressure from those speeds. And if you just look at the difference in the level plane flying and the rocket that's flying, you're going to have to come to the conclusion that if a rocket follows that path to follow the curve of the Earth, airplanes would too, but we don't see that. We see straight lines, and the straight lines dip into the horizon because of perspective, and you're going to learn that today. Over a 2,200-mile flight and 1 hour time, this airplane would need to overcome 432 miles of curvature. And the globe people are going to try to tell you it's 1 mile at a time, which doesn't work because their curve of their Earth would be physical. And if the physical Earth curves 432 miles over the distance of 2,200 miles, then you're going to have to overcome that to maintain the altitude as you fly straight and level over the Earth. And in the meantime, you also have to remember that the Earth is also rotating. And the globe people like to say everything's moving together, but if that were the case, it'd be like a river. Rivers flow in one direction, and if you're not going against the current, everything's fine and dandy. But if you try to swim against the current, that becomes a problem, and you will realize really quickly that that current's going to slow you down. But we don't see that in airplane flights. We don't see that in wind. We don't see that in anywhere over the Earth. Just want you guys to think about how big the Earth would have to be for that rocket there, that parabolic maneuver to somehow orbit the Earth, right? Because if that's all it takes to get over the Earth, they're telling you that when your entire line of sight covers the entire Earth, because they're going around it. So not very good. And as Globeman was talking about seeing the curve from an airplane, it's not the flat earthers that disagree with you. Well, we do disagree with you, but Neil deGrasse and others have done the math to see whether or not you would see the curve from even 53 miles up during Richard Branson's flight to space. He went 53 miles up. I got a video here we'll play later of Neil deGrasse talking about how you can't see the curvature from that height. And airplanes fly between 5 and 6 miles up. Richard Branson went 53 miles up and didn't see the curve. Same with Felix Baumgartner. He didn't see the curve at 23 miles, but we're expected to believe we're seeing it from the ground, as Globeman showed in his intro, and from the air. And if you notice too, the curve doesn't change as far as how much curvature you see on the ground versus up. Even though the higher up you go, the angle would change. You would see more. It's always the same, never enough to be the curve of the Earth. And what we're looking at is refraction here. And I've got a quick little video here. If you guys don't mind, I'd like to play it. Talking about how gradients in the atmosphere changes, or in this case, this tank changes the way light travels through it. So this is just a quick little video.
I don't think you shared with sound, so go ahead and narrate.
Oh, shit. Dang it. Hold on.
You could just narrate, like talk over it. You don't even have to reshare.
I could share it right here. Hold on.
on.
I got it. I got you. All right. We'll restart. Sorry, guys.
Regular water, so all the
Okay.
sugar that dissolved in the water stayed at the bottom. Basically what that does is create a density gradient where it's densest at the bottom and least dense at the top. So if you think that you haven't seen this phenomenon caused by this gradient index, you're probably wrong, because this is the same phenomenon that causes mirages.
In fact, a little bit better than laser light, you can follow the path of the bottom corner of the box and look how bent it looks. So watch as I get down low, watch the background here, watch how it lenses everything. In fact, it makes it look like there's a slope here. So you can see the edge going up there, but there's actually not a slope there. It's actually just flat. You can see it's just flat like that.
Add sugar, what you do, you fill the tank with water, then you pour sugar in so it lays in the bottom. The sugar at the bottom starts to dissolve, and that makes the refractive index, the density, essentially the optical density of the water, will be higher lower down, and light bends towards a more dense medium, which is what normally happens.
And just real quick, guys, cold air is more dense than hot air, and air coming off of the ocean is going to contain a lot of water. And if that's the case, as the light travels to your eyes, it's going to be moving through a more dense medium, and it's going to bend. And as you just saw, it bends downward, not upwards.
How much time does Derek have?
That was the 5-minute bell, so he's dipping into.
I'll finish up. So here's the what they did was they put a skyline behind this, and as you can see, it compresses it to what we actually do see when we look long distances over water. And yeah, I've got another video I'll show later, but yeah, game over, guys.
Okay, and Globe team went over about 5 minutes, so Austin, you have about 5. I'm sorry, they went over 1 minute. Austin, you have a total of 5. You're muted, though. I don't know if you know that.
Oh, my bad. Okay. So, cool. I'll share the screen. Let me back it over here.
Okay.
It's all good. Just kind of riffing anyway. Okay. Share screen. So, there's a lot of claims that I would like to address. We'll just address them during the debate. I think it's best to hear it all discussed. But one of the things that people always talk about is the sky. I think that people need to understand a basic concept. I don't understand why people don't understand this. It's just common logical sense.
Are you sharing? Sorry.
I'm about to share it now. Yeah. So here it is right there. So the globe Earth was quite literally designed from the sky. And so if people don't even understand the basics of how we came up with the globe, to come in on the internet in 2023 and pretend that they're slam dunking on flat earthers is pretty laughable. The way that we came up with the globe was we looked at the sky and we engineered a geometric claim of the earth based on what the sky does. If you turn around and say, hey, look, the sky matches the globe, that proves the globe. That is logically bankrupt and fallacious and ignorant, and shows that you don't even know how we came up with the globe in the first place. So I'll go through this real fast. Of course, one of the things he brings up is the idea that we see counter rotations and that the Southern Cross would debunk it because of where they see it on a flat Earth. And they show you this depiction right here. Now, of course, this is from Not a Professor Dave, and this is laughably a straw man, right? That's not the direction those people actually look. I wonder why the Globers always leave out the true directions. So let's look and see what Stellarium shows as the actual direction so we can get to the bottom of this. Here's a Southern Cross. They all are at 2140 UTC. You can see that down here in the bottom right here, we have Salvador. You look at the top right, you can see where we see the Southern Cross. Oh, look, it's all the way down at the horizon, and it's never exactly south. It's always southwest. We look over here, also southwest. So all three observers from Salvador, Perth, and Johannesburg see the Southern Cross southwest at different positions in their sky at the same time. So when Globers turn around and they say stuff like, we see the stars at the same place in the sky, all looking south on the globe, that's actually patently false. Even Stellarium disagrees with you. That's not where we actually see it. So if you want to see a little depiction so maybe you guys can understand it, here's a quick video. Oh, I may not have shared with sound though. Oh, you have to click the little box, don't you?
The 3 dots and then scroll down. You'll be able to do it.
I'm going to reshare, share sound, bang, bang. All right, so I think he narrates this pretty well. Couple slip-ups, I'll just play it.
So the best way to explain the Southern Cross observation from 3 different locations in the Southern Hemisphere at the same time is the Walter Bisland's model. So we have one in West Australia, one in South America, one in Africa. If we say that this is the star on the sky that we're all going to resemble, see, it's right over Africa. Say this is the star that we're going to see it. This is the one we're all going to see, right? Crap, screwed up. Let's say this one. This one's the one we're all going to see.
All right, so look at this star right here. Will this represent our Southern Cross for intended purposes to understand the concept?
Let's see right here. So this guy would see it, say right here. This
okay, this purple star is where we are seeing it through our azimuthal grid of vision. That's where the star actually is. As we move it over, there we go. We see that actually this star in the sky didn't change position, but where we observe it did change position, and it happens the same over here. Now, what the ballers try to say is that this would require light to bend in a way that's physically impossible, basically like a script. I like to point it real fast. They always leave out the directions. It's hilarious. They just repeat each other. So when we actually go and throw the real directions, how does it work on the globe? So we're supposed to all look south and see the Southern Cross, but when we put the actual observational directions at the same time at these different positions on the globe, they don't all look at the Southern Cross. So the irony is that alleged evidence has completely backfired. I would love for you guys to explain to me how you're all looking southwest and seeing the Southern Cross at the same time at different positions. You can't. And just to verify the validity of this is not some ad hoc explanation to try to make the globe work, as this dude tries to say, which hashtag thanks Walter, he made the flat earth model for us. You guys just repeat, made this up, but this is an AI basically explaining what you guys are going to say, so we don't really need to.
Walter says light would have to bend for that model to work. Bending light rays. My daddy MC Tune said light can't bend that way. Stupid flurf.
Okay, so that's all you're going to get is bending light rays over and over. So I don't know how much time I have. I'm trying to breeze through this
30
fast
seconds.
so you guys understand the basic concept. We have an azimuthal grid of vision. Now, time and date, suncalc.org, everything that you guys use, Stellarium in the globe paradigm uses this exact model. You take your zenith to the position directly over you. This gives you the meridian along that line. What you're going to do is establish what's called your azimuth. That is your horizontal direction on the horizon. Then we take altitude positions to the stars. We map this out 360 and we get an azimuthal grid of vision of our observability. And that's how we actually map the sky. And that's where we made the globe from. So this is how we actually see. We have that 360-degree field of view if we turn around, and this is how we map the sky. Now, what we know is that when we look at reality, we have crepuscular and anti-crepuscular rays. So what this shows us, if the sun's coming from over there, but over here, it looks like they're converging down to the horizon. Well, this is an optical effect of perspective. That when we look around, we have a convergence. The sun is setting in the opposite direction as this is. So we know that we have a dome of vision effectively. Even in the globe paradigm, they have to invoke this to explain anti-crepuscular rays. So when we look into reality, they want to claim that these light rays are parallel. But if we look at it in the side of a dome of vision, we would see this curve right here. If you look closely, you'll see it converging on the horizon to the left, converging on the horizon to the right, curving to combine the two. Well, this is what we would expect in an azimuthal grid of vision. It would curve. So the globe claims that this is parallel, but it's not in reality. We see the same thing with, domes in the sky, right? And then we can see the dome of our vision replicated on a smaller scale. We have moon halos, sun halos, perihelions, all kinds of things. So in summary, the whole idea that we're looking in opposite directions with this little strawman cartoon 5-year-old model here, where we're looking opposite ways, is a joke. It's a straw man, and in fact, it backfires on the globe. They're all looking southwest. They're not looking south. They're looking at different angles. When you map them on the globe, they're not even all looking at the Southern Cross at the same time. So if you actually accurately represent it, of course, due to time zones at different times, they're all just looking south. This is a Mercator projection, of course. They're all just looking relative to their dome of vision, and that we can prove that this is how we see. And when we take the actual data, it works perfectly on the flat Earth. So it seems that this has backfired on the Globers, and hopefully they actually understand what I'm saying, but I'll be more than happy to get into it. Jaren, how much time I got left?
That's it. Let's end it.
Okay, cool.
But just to point out,
so we'll get into the rest of the specifics.
Sure.
So let's get it.
In the future, though, guys, that's why we don't want to say at the beginning. I know you guys told each other, "Hey, it's okay if you go long," but that's why you don't want to do that, because then you start, people are itching at it. Like, why is this guy going so long? It's just, I wouldn't in the future do that. We should stick to the time. Do you guys want to do open conversation? Go ahead. You can do that as you want. If it gets too crazy, if you're going to talk over each other, then we can do a time thing. But we can try and open it up at first. Go right ahead.
Sounds good to me.
You want to address the star thing, since that was the last thing mentioned?
Yeah, how does the light bend nearly 180 degrees?
So you didn't listen. So
No, I did. I mean, yeah, refraction happens, and we both agree that perspective works, right? We both agree that that railroads look like they converge to a point, but that's not a 180-degree bend.
Okay, first of all, the light's not physically bending; it's an optical effect. So can you let's meet in the middle here? Can you explain to me how anti-crepuscular rays work on the globe Earth?
Yeah, it's the same perspective thing as railroads.
Right. So what I just showed in the presentation is actually when we look at them from the outside, we see them curving. So if I had a railroad track going over top of my head and I looked in both directions and saw them converging, they wouldn't be curving. Why are they curving?
Right. In Walter Bislin's the thing that you pulled up, if you there are particular stars that you can see, the light comes over and then to the front, or to the so light comes from the north, or from I guess from the other side of the world from your perspective, comes over the azimuthal field of view, and then comes in from the other side. It bends 180 degrees around. How does that work?
Actually, it doesn't bend 180 degrees.
Nearly 180 degrees.
You just made that. Yeah. So you guys always.
No, I can show you a picture.
You always do that.
I'll share my screen.
But this is what's interesting. You didn't answer my question. So whenever we have anti-crepuscular rays on the globe, and you said that it's like railroad tracks, I just explained, well, how come when we look at them, they're curved? So if I have a point on the horizon that looks like the light rays are converging, and then I have a point on the opposite direction, 180 degrees, where it looks like the light's converging, and I draw a line over my head from point to point, I'm going to get a curve or a dome. So how come when we look at them in real life, we see them curving from point to point? How does that work if it's like railroad
we
tracks?
both agree that perspective is a thing.
So you're saying perspective makes things curve?
Yeah, of course, but not 180 degrees.
Okay, so perspective's not purely Euclidean geometry, and it actually makes things curve.
I mean, yeah, perspective is a projection from Euclidean space to a hemispherical space.
So it makes the parallel light rays from the sun appear to curve to each convergence
diverge
point.
or to converge.
Well, no, but it curves from point to point, though.
So I don't actually know what phenomenon you were talking about. You were talking about like this bowing effect. I mean, the parallel light rays behind you and in front of you, yes, that's a diverging or a converging effect when you see corpuscular rays or anti-corpuscular rays. I don't know what other light effect you were talking about because you didn't name it. So
I just showed the picture of the convergence.
Right, but you didn't actually tell us what it is.
Yeah, when you look at the convergence on each position of the horizon, they curve to meet each other. So see if you can answer this.
What?
If there's
what is this a picture of?
It's a picture of the actual light from the outside on the Earth. Like, see if you can answer this. If I have a point on the horizon, right, and say it's in the west, and then I have a point that's in the east on the horizon where these rays look like they're converging, right? If I'm going to connect the point to the west and the point to the east, and it goes over my head, what am I going to get?
You'll get something that looks like it's converging towards an infinity point in front of you, and it'll look like it's diverging from behind you.
Okay, so if I want to connect the 2 points with a line, but it has to go over my head, what do I get?
So are you connecting them in real life? Are you actually asking the path that the light takes, or are you asking what direction does it look like the light takes?
Sure, do the latter.
Of course it'll look like it'll curve over you, sure.
Okay.
Nobody's denying that.
So you're
but
admitting that the light's straight, but it looks like it's curving?
Yeah, except again, this is a bowing effect that you'll see, right? You'll see a bowing effect. You will not see something bending, going straight, and then bending around, which is exactly what Walter Bislin's model does, which you cited.
First of all, you actually just said it again. It doesn't bend 180 degrees. That's
I can
patently
show you.
false.
Can I share my screen?
Yep.
Just
Yeah,
so I can
sure.
show?
I would love to
Okay.
show me 180 degrees.
Sure.
And by the way, on Walter's model, these are arbitrary stars
Here.
he placed in the sky, right?
This,
These aren't
see
actual
this,
stars.
See this right here? That red
Yeah.
ray? See how it
Yeah.
bends? Nearly
Yeah, can we see
180
that star in
degrees.
real life?
Apparently, yeah. You would say that you could because this is a southern star.
Really?
Cool.
So when we're
Mm.
on this side of the Earth, we can see the southern star at night, the same time the other observers are seeing the southern stars?
So which stars do you think that you should be able to see?
These are not real stars. Did you not know that? These are arbitrary, made-up stars.
Of course they're not, but this is the model that you brought up. So I'm just
Yeah,
saying that
so-
your model is absurd.
This is awesome. So yeah, the anti-flat earther Walter Bislin made this model, and he found out he couldn't debunk it. So what he did was
which stars are real?
Debunks
You're
itself.
freaking out. You're freaking out. So these are
also finish.
arbitrary stars. These aren't real stars. So you just drawing random arbitrary lines to stars doesn't somehow debunk flat Earth. Let's look at what stellarium and the actual observations show us that we can truly see, and then we'll map it out. And guess what? It works every time. So these arbitrary made-up bendy light rays mean nothing.
Did you miss my presentation where I showed you stellarium and I showed you the Southern Cross south-southwest for both those observers?
Did you miss my presentation where I specifically addressed
Yeah, that was-
exactly what direction they're looking?
You didn't. That was a different time of day. That was a different date. So yes, they do.
That doesn't matter.
rotate. Of course it matters. It's going to change where they are in the sky. Why
Yeah,
wouldn't it
but
matter
you-
which date we do it on?
You
So
claim that
I showed you July. I showed you July, the date we did the observation. And the Southern Cross was south-southwest for both those observers. Do you disagree now with the stellarium data?
No, I just invoked the stellarium data to show that they all look southwest, and I show that it doesn't even match on the globe, and that
On
it
a
matches
different
perfectly.
day. You're dodging my question now. That's a different day, right?
Wait, it's the same effect.
It's the same effect. So on this day in July, the Southern Cross is exactly south-southwest. You see my screen?
Yeah.
Okay. So if I go to Australia, the Southern Cross is still south-southwest. It's just lower in the sky.
It's
Okay.
frozen, by the way.
You didn't move. Yeah.
Yeah, it's not updating for some reason when you
Well,
use
it doesn't update when I switch. Now, how about now? Maybe it might just be delayed.
Yeah, okay, it's
good now.
it updated
Okay, so
now.
there's the south-south. There's the Southern Cross again, exactly south-southwest. So this is the stellarium data that you just referenced yourself. Different date and time, sure, but this is the stellarium data. So now you showed this. Now this person in Africa or South America here is looking southeast, and this person's looking southwest.
Okay, so this is
Why
a
don't you
Mercator.
make this work to match the real life observation that I showed you, which is this
Yeah.
person here in Australia looking southwest, and this person in Africa looking southwest.
Yeah, it appears you didn't. Maybe you didn't understand my presentation, right?
But
But
I didn't apparently because you didn't answer the
I get
question.
it. I get it. So you guys need to understand some basic things, okay? The light doesn't physically bend. It's just an optical effect based on your limit of perspective. Do you understand that distinction?
Sure.
Look at your
Although light does bend occasionally, there is refraction. We
That's
both
that's
agree on
called
that.
that's called a non sequitur. So it's irrelevant.
Okay.
Okay. So let's stay on subject here. So the light doesn't physically bend. It's an optical effect due to limit of perspective. Now,
That
your
doesn't mean-
paradigm does not claim what Blitz has already claimed. He quickly had to concede that, oh yeah, it'll make it look like it's curved. Well, your paradigm doesn't claim that. Your paradigm claims that it's parallel raised. It does not claim that perspective alone can make it look like it's curving from point to point. It objectively doesn't claim that. So you've already conceded my entire position. As soon as you claim that perspective causes it to look like it optically curves, you're now admitting that all celestial phenomena ever works on a flat Earth. You understand that?
I mean, you're putting words in my mouth. That's not what I said.
You did. You said it would look like it's curved.
We all hold on. Everybody in this channel will acknowledge that railroads look like they're wider when they're underneath you and narrower ahead of you and behind you. That's what a curve looks like. It looks like it's bowing out behind you, bows out at the middle, and then comes in. That's exactly what it looks like. We all acknowledge that. That doesn't debunk the flat. That doesn't debunk the globe Earth.
And furthermore, I wanted to add one more thing.
What's it? That's an ad hom. Don't do that.
I
just wanted to say one other thing
Go, man, go.
to add to this. So you had mentioned the crepuscular and anti-crepuscular rays, and that's kind of what we're talking about now. So anti-crepuscular rays would not be what we would expect on a flat Earth with a local sun, going above it, right? Crepuscular rays, that's perfectly fine. But again, just as Blitz said, it's going to be just the same thing. It's going to be parallel lines appearing to converge in the distance. And anti-crepuscular rays prove that. Because if all the light was just truly going outwards and away from the sun, like the flat Earth would predict, we would not see that converging effect. They would literally be moving away from each other.
What? Dude, you don't. Okay, first of all, perspective is just a thing that happens, okay? And how to interpret perspective is significantly argued amongst the highest levels of academia, whether visual space is Euclidean or hyperbolic, because it gets into intricacies. You can actually look into robotics, and when they begin to precisely match out the optics of visual space and robotics, they realize Euclidean geometry does not work. And we do not have a proportionate linear relationship with optics. It doesn't matter. We see them converge in both situations, whether the Earth is flat or a globe. The point is that when we see them converge in both directions, the sun's not actually 180 degrees behind me when it's setting in the west. So why can I turn to the east and see it? You're saying they're like railroad tracks. So again, the follow-up question is, how come when it goes from east to west, there's a curve that connects the two convergence points, even if they're optical? Why does it curve? According to you, it should be parallel. Over my head, it should be directly straight.
How come you can't look to your right and see that same sun crepuscular rays to your right? Why is it only bent 180?
So you just completely avoided the refutation of your position with a complete out of left field red herring question?
Crepuscular rays don't answer this star question.
Local sun.
Okay, so you can you answer my question? I'll happily. That's ignorant. So wait, in your paradigm, does the light from the star
who doesn't
travel?
ad hom, you certainly ad hom a lot.
If my argument was an insult, that would be an ad hom. I haven't done that once. So,
yes, you did.
No, I did. My arguments are very specific and have substantive.
You want to go with poisoning the well with it?
I'm not doing that. Hey,
have I called you ignorant yet?
I just you guys are freaking out, man. You guys
have I called you ignorant? You're just insulting.
I said your position is ignorant. And I'm explaining why.
Okay, go, Austin, or we're going to go to timed things. Go ahead. Give a minute. Go ahead.
Okay, so I'm asking specifically, why does the optical convergence point on each horizon connected curve? And Blitz immediately conceded, oh, well, yeah, perspective will make it look like it's curved. But he didn't know that was a trap. Okay, so if you concede that, then you concede the entire flat Earth position of the azimuthal grid of observability explaining all celestial phenomena.
Connect that concept that you're trying to state to this, okay? Now look, this pink star, the star with the pink line, is exactly where the Southern Cross was in our observation from South Africa. Now, if I move this over here to Australia, now you're saying this, well, it got rid of the pink line. I'll do it right there. Now you're saying that optically, whatever that means, which means nothing, optically, this light is bending around almost 90 degrees to this person standing over here. And now that person is seeing the same star looking southwest, but the star's really over here. That's what you're saying.
So first of all, you understand that it's dropping on the horizon as you get further away from it. You understand that, right?
Altitude doesn't matter, and I do understand that. We're talking
about
so then
direction. It's a product of perspective then, right?
Direction, south-southwest. How does south-southwest work for both those observers?
Right. So I showed it in my presentation. All the audience can go back and watch it. But if you look south-southwest, listen, dude, you have an azimuthal grid of observability. So as you get further away, it's going to optically drop. That's due to perspective. We can actually map it out, and it perfectly works in an azimuthal grid of vision. The ironic part is it doesn't.
No one's talking about height, though. No one's talking about height. We're talking about cardinal direction. Both those people had compasses, and they both were pointing south-southwest.
Yeah, southwest, yes.
South-southwest.
Yeah, and it keeps on getting closer and closer to southwest, right?
No, they were both south-southwest.
So they're the exact same direction?
You're avoiding the question now.
No, I'm not. I
I'll go
explained
play
it in
the
my
video on my
presentation.
YouTube. I will go play the video for you right now. They were both looking south-southwest, and that matches the stellarium data that I showed you twice now.
The
They were
stellarium
different-
data is what I'm using to explain to you why it doesn't work on the
They
globe.
were at
You're just
different
not even
altitudes
understanding
over
it.
the horizon. I agree, different altitudes.
Right,
Because
okay.
they were at different parts of the globe, but they were both looking south-southwest, which is the part you keep avoiding.
No, because when we're looking out away from the natural rotation of the sky, we have an azimuthal grid of vision, and it's going to cause these optical apparent positions to change relative to our position. We see the same thing with the sun. We see the same thing with the sun. And the reason I had to bring up anti-corpuscular and corpuscular rays is because what you guys don't get is you have to invoke the exact same construct to explain the globe. You literally need this for suncalc.org, for time and date, and for stellarium. This is how we got all of our observations.
we all
of it
acknowledge-
uses an azimuthal grid of observability. Do you guys understand that?
we
Yeah, you
all
can keep
acknowledge
saying the
that
word
we-
azimuthal grid, but that's not an answer to the question of why they're looking south-southwest.
Because you can demonstrate that when you look through curved visual space, the apparent position is different from the actual position, even though the light's not physically bending. It's a perspective of optics.
Just
hold on. So
You're
look
just saying
outside
the word
that.
optics.
You can prove it.
Look
Yeah,
out. Wait, no, actually, Witsit, prove it.
Okay, so you can take even just a little dome, and you can actually show the difference in the apparent positions and the actual positions with a little dome, even a paperweight.
Have you
and
done
we can
this?
actually we can prove this by what?
Have you done this?
Yes. Yes.
Where?
Absolutely. I have it in my PowerPoint. And we
Okay.
can also
Pull it
show
up,
what I
please.
explained to you. I showed you the direct observation of the optical convergence points on each horizon curving to meet each point. Your guys are claiming that they're parallel and they're just like railroad tracks. So why are they curving?
It's a different topic, Witsit. That
It's
doesn't
the
answer
same
why
topic.
two people are
It's
looking
the same
south-southwest.
topic.
It's a
You
different
don't
topic.
understand why. Good.
You're literally.
To be clear, the perspective doesn't occur until it's inside your quote azimuthal field of view, right? It's, like in this picture, and yet there's curving outside of it. How does
No,
this
see,
work?
so this is what I'm saying. You guys don't understand it. This guy drew arbitrary stars in the sky.
Then
He
why
put
did you use
arbitrary
that?
stars in the sky,
arbitrary.
and then
We
he
can-
arbitrarily determined the curve that would go to
So
the
then,
observer.
why did you use it? How does
Because
it work if not this way? Please explain.
You said this
Okay.
models everything we see in reality. That's what
That's
you said.
That's right, but these stars aren't actual star positions. You don't get that?
We can assume one is close because it is close. This one's very close to where we observed it in real life. This pink one here.
Okay.
We went over that. So again, you're not explaining, but you're just saying the word optics, and that doesn't explain why two people can look south-southwest. I did this last week again, by the way. I have that video. I haven't posted it yet. We got a better view of everybody's compasses. Looking again, that one was southwest and south-southwest, so it was a little different than this observation because it was different time of year.
So when I say optics or perspective, how is that somehow different than when I ask you why the anticorpuscular rays happen and you say it's perspective? How is it different?
Well, hold on. We all acknowledge that perspective happens, right? We all.
Well, no,
took
he
art
said I'm
class
just
in ninth
saying
grade.
words, though.
You
Well,
are
I mean,
a red
like you're saying
herring to a crepuscular sun rays. It's a red herring.
It's not a red herring.
We all know that refraction happens because we both used refraction in our arguments. You guys use refraction to explain why there's a horizon dip angle. We use refraction to explain why you can see further than you might be able to than you might expect on a globe Earth. You are invoking perspective as to why these rays bend 90 degrees. We're invoking perspective as to why railroads appear to converge. We both understand that these are all happening. The question is you have a burden here to explain why we can see something that is south-southwest, and an answer is not azimuthal field of view. That's not an answer. You actually have to explain how that works. How is it that the light that the light, which would appear that way if you were just looking directly at it, suddenly, because of your field of view, appears that way?
Yeah,
that's on you. That's what you have to prove.
And forget the Southern Cross. The Sigma Octantis is right in the center.
You can't even see Sigma Octantis with the naked eye or majority of telescopes. Why are you? It doesn't matter.
A majority
if you
of
can.
telescopes. That's not an answer, Witsit. It exists, and people see it with their telescopes.
No,
So
when you
don't-
say people see it, you mean people that you blindly believe, like observatories. And it doesn't matter if it does exist or doesn't exist. It's the same argument. There's an optical
So
convergence.
the constellation Sigma.
It's maybe too complicated of a
Octans-
debate subject.
Yeah, we might want to go to a different topic.
You guys don't understand.
Hold on, hold on.
about
Witsit
gravity?
just said Sigma Octantis doesn't exist.
I did not straw man fallacy.
We're doing a lot
just
of
said it
looking
doesn't
at the
exist.
sky right
I said it doesn't matter if it does or doesn't exist.
It does because it's the
Derek,
South Pole
go
star.
ahead,
and
Derek.
it's
What is
seen
Derek's
due
Let's talk
south
about
of
gravity.
everybody.
Hold on,
Gravity.
Derek.
We don't have to look at the sky. We don't have to look at the sky to talk about
Hold on,
gravity.
Derek
Is that fair?
keeps showing this piece of paper. Derek, what are you showing?
So this is if this was the actual star, when you're viewing it from here looking up, if this is your azimuthal grid of view, this would be its apparent location from here, and this would be its apparent location from here, even though they're in two different spots. Now, if you were seeing the actual location and it was lower, you'd be looking in the same direction. So their argument would work if this were the case. But if we're arguing that you have a grid of view that's a dome and you're seeing an apparent location and not an actual location, depending on how high this star is above your grid of view, it's going to actually widen. So the further up this gets above my paper, the wider it's going to be. Same this. If this one got higher, it would get wider this way. So this would perfectly
south-southwest. Make it south-southwest for both observers, Derek. You can't do it doing that.
Yes, you can.
If I move this higher, that's what I'm saying. If I move this higher, it widens out.
It'll get to at most 90 degrees, but it'll never turn around the other way.
Yes,
And
it'll
if it's
get
not
90
exactly
degrees.
over this middle, if it's not dead center, so if this was over here, then it would be south-southwest.
Mark
Guys,
two
you can
spots on your
replicate
piece
this
of
with
paper.
little domes. You can watch that. If you took a little dome and you took a light and you moved it over in a circle, you're not going to see it move to your right like it's setting to your right in a circle. You're going to see it completely displaced based on your dome of vision. You can literally replicate it. That's why I showed you a real life observation of the crepuscular and anti-crepuscular rays from the outside converging to the point on the horizon and then curving from point to point. That can only be explained with the fact that the curve is a product of perspective.
That has nothing to do with what we're talking about again.
It does, though.
Derek, can you take
literally
that piece
does.
of paper, Derek, and make those lines look south-southeast for each observer?
If you change
southwest.
if you change the actual
Southwest,
location to where you are and its height, if you knew the actual data, you'd be able to do it. But I'm not going to sit here and pretend like
Because
we
you
know
can't
how
do it,
high the
Derek.
star is versus without the actual data. Globy, good call.
No.
Way to be smart. If
There's
you
no way
don't
to do it
have all
direct
of the
in
actual
principle.
data, you can't prove it. You could speculate, which is what this is. I'm not sitting here saying this is exactly where the star is over this and but no. I'm showing the viewers that dependent on how far the star is above your grid of view, its
Okay.
apparent location is going to change.
just
Until
for
we
all-
actually, you want to let me talk? You asked me to talk and then you want to interrupt me.
Go.
Not very cordial. Depending on how far above the star is and its actual location, it will change. And beyond that, on the flat Earth, north is the center. So if you're not looking north, you are looking south. And there's this thing called magnetic declination that changes the apparent location. So if you're pointing your compass south in the southern hemisphere, it says south, sure, but you're not taking into account the magnetic declination that has 10 to 40 degrees change, where you have to adjust by 40 degrees from what your compass is pointing to actually have an accurate location that you're looking.
I did that in my observation.
Did you
know
use
the-
compass
do you know what the
correction in your
magnetic-
observation?
Do you know what magnetic declination is from Australia? From
Yeah, it destroys the globe.
Yeah, absolutely crushes.
Does it really?
Do you know what?
Hey,
do you know what the magnetic declination was from Australia when we did?
It depends on what part you're
fluctuates.
talking, but
Okay,
yeah,
so you
it's-
don't. So you're saying that's an excuse, but you don't. It was -1.
Oh, gotcha.
-1.
Highest levels of academia admit they can't explain the southern magnetic declination. So it seems you should explain it to us since you
Yes,
know
that'd be-
somehow.
Yeah, let's hear it. Globy.
Magnetic
Let's go, come on.
declination is
Explain it.
-1 from Australia. So I did adjust for that. You know what -1 means? It's negligible. You take -1 off the degrees on the compass.
You
Was it-
adjusted
was
for
that an
something
appeal to
negligible?
authority?
Wow. No, it
Was that
wasn't
an
an appeal to
authority?
authority. I'm saying that in the hostile witnesses, there is no accurate way. So if you want to explain how you
There is an
map out
accurate
the
way.
magnetic declination in the southern hemisphere, I'm all ears. I don't care about
I
authority.
mean, hold
Enlighten
on.
me how it
So
works.
magnetic declination can be measured. Whether it's true or not, and I actually don't think this is true, that it can't be explained is a different story, but it
think
certainly can be measured.
Oh, so you don't know, you just don't think it's true. Well, okay, we can
No,
move on.
you didn't cite any sources, you didn't
Let's
cite any
move on to
academics. you
What
didn't cite any
about does
papers.
Harvard work?
And
I
stop
mean, like,
spin-turning,
yeah, you
Globy.
can bring something up. That'd be cool. But yeah, let's talk about gravity. I'd like to hear you guys'
Let's talk about
explanation
gravity.
for
That would be awesome.
general relativity or anything.
Let's do that.
Yeah, so this is what's so funny. When you said that like relativity works so well, that's why are you? That's just patently false, right? So it doesn't work on the quantum or cosmological scale. Do you want to pick one of the scales that we can destroy?
I mean, nobody's claiming it works on the quantum scale, but that's fine. I'm talking about on the macroscopic scale, the scale that we can measure in a laboratory here on Earth.
You literally invoked quantum scale in your opening.
Yeah, that didn't have anything to do with gravity. I was talking about
You
quantum
said it was the
electrodynamics.
most accurate model that we have. So
Yes,
you're
quantum
gonna sit here and say that
electrodynamics.
it's the most accurate.
Quantum
but that we don't
electrodynamics
use
is the
it
most
for
quantum
describing-
dynamics is the most accurate model that science has ever produced. Yes.
Yeah, electrodynamics, right? So it uses
quantum electrodynamics. Yes.
That's right. So it
Has
uses
nothing to do with gravity.
electromagnetism. It has nothing to do with gravity. Gravity's
No,
nowhere
but
to
it
be
has
found.
it has to do with special relativity, by the way.
You want me to pull up since you have a PhD and you're claiming that you fully understand the quantum relationship of gravity. How about I pull
Hold
up
on,
a source?
I didn't make that claim.
Well, you said it worked perfect in your opener.
Yeah.
It works perfectly in all the regimes in which it applies. Nobody is seriously claiming that we have a theory of quantum gravity. And if you think that that's what I'm saying, you're strawmanning me.
Actually,
Well,
some are, but of course, as electromagnetic nature of gravity, then they draw an equivalence.
Who?
But they draw an equivalence between Constantine Mice. He actually draws.
Yeah, I know that paper.
Yeah, and let me guess.
It's
Let me
garbage, by
guess.
the way.
Yeah, he's garbage. So you just
No, I've read
committed
it. Have you read the
you
paper?
committed you committed a genetic fallacy.
No.
So
I didn't even know who he was.
this
I've
random
read the paper.
anti-flat earther on TikTok, who appeals to credentials and scientists all the time, as soon as a guy who is the lead scientist
did I
at the
do that?
Nuclear Physics of Institute seems to disagree with him, he doesn't. Now all of a sudden, credentials don't matter.
Equations
so
18, 19, and 20 are false. Yes,
you
equations
refute the
18,
paper?
19. Yes, equations 18, 19, and 20 are false.
How so?
They don't agree with experimental data.
What,
also, they're
what
not
experimental data? It uses
Yeah,
vacuum
so-
electromagnetic energy from
Hold on.
energy
Do you know what
density. That's
equations 18,
provable.
19, and 20 are?
It says it uses vacuum energy density from an electromagnetic vacuum. Does that not exist?
Electromagnetic vacuum energy is fine. Do you know what equations 18, 19, and 20 are?
Off the top of my head, do I know what the equations are?
Okay,
No.
so equations 18, 19, or 20 are a relationship between the mass of fundamental particles and the so-called magneton of these fundamental particles, and the Bohr magneton. And there is some integer relationship that's claimed to relate these two things. So you have the mass of the fundamental particle is an integer multiple of a certain fundamental quantity that he claims that we can measure. Fine, we can measure that fundamental quantity. The question is it true that the mass of these fundamental particles are an integer multiple of this particular quantity? The answer is no. The answer is experimentally no. His
What
model is
fundamental
incorrect.
particles?
All of them.
See, so now I know you don't understand the paper.
I mean, he has a table. He has a table. He explicitly gives a table. It's he even for a muon, he's off by more than 0.5%, and he doesn't even account for the mass of neutrinos because neutrinos have mass smaller than the mass of an electron, which is required. They have to be bigger than the mass of an electron in his model. So like it's patently false. This article.
No, you don't even the mass of the electron, dude. You don't want to get into the mass of the electron. I promise.
Wait a minute,
dude.
hold on. So can you acknowledge anything I just said? That
Yeah,
this paper makes
you
claims
just
that are false?
you're reifying made up.
I'm not
units of
reifying
measures
anything.
from
I'm
quantified-
debunking.
yeah.
I'm debunking the
You're
paper that you brought
freaking
up.
out. You're freaking. So this just so the audience knows what the paper is, right? So it's a guy proposing a gravity in an attempt to address all the cosmological and quantum discrepancies with the current gravity, theory, and it's completely wrong in every aspect. He said it was 99% accurate. Actually, in 33, we found out it was 99% inaccurate. Looking at the galaxy clusters in 1933, Fritz Sawitzky found out that we only had 1% of the mass predicted by gravity. So it's 99% inaccurate.
Do you have an answer to my claim that it's 99% accurate?
He's addressing the actual issues with gravity in the current paradigm, and he's explaining that, look, you can actually show using the energy density of an electromagnetic vacuum, which relativity does not even address, then you can actually use that, show that gravity is not a universal constant. It's intrinsically electromagnetic in nature, and then you can draw an equivalence between Coulomb's law and what we call gravity. And he shows exactly how it works, and it is testable by using the energy density of each position in a vacuum and then testing it for the gravitational results. So have you actually tested it that way, or have you just reified particles?
You can't directly measure the vacuum energy. It's not
So
a thing
we
that you can do.
Okay, so we can't detect electromagnetic fluctuations in a vacuum?
No, we cannot empirically, experimentally measure directly the electromagnetic vacuum energy. We can only do it via particle collisions, which again, I guess you're assuming don't exist.
Okay, well, just what you call particles, yeah, and assuming the materialistic nature of them, of course, it doesn't exist. Of course, QFT has now already inched their way to saying it's actually background fields with oscillations and excitations. And we just call them particles. We just call them particles for intents and purposes. You guys are just inching towards an ether. But this is the truth that I'm trying to point out. Can you acknowledge that there's a huge gap in what gravity claims to be and experimental evidence from both the quantum and cosmological scale, and that people at the top tier of your paradigm are currently trying to fix those problems, and one of the primary fixes that are being proposed is unifying it under electromagnetism?
Yes, and no. Yes, there are problems at the quantum scale with gravity. This is a problem known as the quantum gravity problem. Yes, there are problems at the cosmological scale, but not the ones that you brought up. There are problems involving basically dark energy. The leading theory is not unifying it under electromagnetism. That's patently false. And for what it's worth, I work with these people. I know who they are. They're not doing this.
What's the leading unified field theory then?
So string theory is the one that people really, really like. I don't really like it, but that's the one people do like. People also like loop quantum gravity. I think that's pretty good.
That's
but again, I don't
electromagnetic.
really like it. Loop quantum gravity is not electromagnetic.
Yes, it is. It says that there's a background medium that interchanges all.
It's an SU2 gauge theory. It's specifically non-electrodynamic.
Okay, so what you're saying is that you think that the attempts to unify under electromagnetism are less efficient than string theory and loop quantum theory.
I didn't. So the attempts to unify it under electromagnetism are just like patently false. String theory and loop quantum theory are just hard to test. Now, I don't think that those are true either. I don't think anybody has a good solution to quantum gravity right now, but this guy, this Konstantin Meis, certainly doesn't. By the way, did you look at his references? Because he cites himself in half of his references.
Okay, he has tons of other references.
Data for this. Right. But for the equations that matter, and again, this is how I know that you didn't actually look at this thing in any sort of detail. Because for the equations that matter, he either doesn't defend them, he just says them, doesn't derive them, he just says them, or he cites himself for them. Like,
okay,
this is
what's so funny.
This
is what's so funny. You just admitted that the leading ones don't work and you can't even test them. And then your primary critique when I brought up the actual electromagnetic density and the vacuum energy density, you said, "Oh, we can't directly test it." So it's so funny that you get to pick and choose.
Those.
The truth is, you have a religious bias toward relativity, which has been.
Is this a red herring? I'm literally not defending those.
No, I'm addressing specifically what you're saying, right? Like you're saying that you know this one's wrong and it's patently and experimentally false, but then you're claiming, oh, well, we can't directly test it. But then you bring up the two other leading theories claiming that you can't directly test it. And let's just make it sure the audience doesn't get lost and we understand what's going on. You just now claimed that I was wrong about what I said about how gravity's wrong for the cosmological scale. So can you please enlighten me how I'm wrong and you weren't off by only observing 1% of the mass predicted by gravity in 1933, and that was the initial discovery of dark matter
has been like indirectly observed. So
what is
like
it?
I don't know, but we don't have to know something to see it.
How do you indirectly observe something?
Yeah, how did
gravitational
you
lensing.
do that?
Gravitational lensing.
So if you assume the current gravity model and then you see the discrepancy and isolate how much it's off, you can claim to indirectly observe something you can't define or prove.
Sure. I mentioned in my opener that science is built as a scaffold, right? Like we build off of previously known experimental works. So like, for example, in 1964, we directly detected in a laboratory on Earth without going to space, gravitational redshift on Earth in a laboratory. And actually, I was looking this up earlier because I was curious how technology has improved. We can now detect gravitational redshift in like a room. You don't even need a skyscraper. You can detect gravitational redshift over the course of 1 foot of height difference. So like this is direct experimental evidence of general relativity. How do you get around that?
Wait, you're saying, wait, time out. He's saying that experimental evidence for relativity is isolating how much relativity's predictions are wrong?
Sorry, what?
If you bring up dark matter, your indirect measurements of dark matter, that's specifically what relativity doesn't account for or predict. You just sat here and told us that you can isolate the idea of dark matter indirectly and that verifies relativity.
I didn't say that dark matter verifies relativity.
Well, that's actually what you just led into saying verifies relativity. So
no, I said that measurements of gravitational redshift in a laboratory verifies relativity.
Well, you just now admitted you needed dark. You literally brought up gravitational lensing to explain how we had indirect evidence of dark matter. So it's like you're being a sophist.
Hold on. To be clear, that's not the only evidence we have of dark matter.
That's irrelevant.
It's just a very good piece of evidence of dark matter.
You brought it up.
Hold on. Yeah, I brought it up because it's a very good piece of. So the reason I brought it up is because general relativity is amazingly correct at predicting things. We can verify it in the laboratory on Earth. So we have good reason to think that it also applies outside. Wait, so do you want to address that claim that we can't verify it on Earth?
This in reality, if we actually do the actual scientific method, then we can like directly manipulate an independent variable, and we can see if it causes the effect. We can't do that with space-time. We can't do that with space-time.
I can tell you the name of the paper. It's Optical Clocks and Relativity by C.W. Cho, D.B. Hume, T. Rosenband, and D.J. Wineland. They explicitly do this. They adjust the height and they see.
So
I mean, have you looked at the paper?
How much
that doesn't prove the cause, man. Go ahead.
Yes,
I'm talking.
I'm sorry, Witsit. How much stronger is gravity over the difference of 3 feet in a room or 4 feet or whatever?
It's
it is
very slightly small.
Very small, but you're testing it, right?
Can I show my screen?
I've heard Globy here say that it is negligible, the difference in gravity from the surface of the Earth versus 5 miles. It's negligible. But you're going to sit here and tell me that we're picking up redshift. Can I please talk? You're going to sit here and tell me that they're picking up redshift in a room. Well, do you know what is also in that room that would be measurable? The electrical gradient. For every 3 feet you rise, it increases 100 volts. So how are you going to determine whether or not you're measuring gravity or if you're measuring this electrical gradient and the shift in that?
Because electrical gradients don't affect the frequency of light waves.
Wow.
Electrical. No, you
No.
did not just say that.
Light waves are, or electromagnetism is linear. So any sort of electromagnetic waves, any sort of electromagnetic fields are just additive. They don't affect frequencies.
See, this is what's so funny is, first of all, you don't even know what light is, and your paradigm claims that it's both a wave and a
I'm pretty sure I do.
particle. No one in your
Straw man.
paradigm knows what light is.
Poison
So
you
for
well.
you to sit
What
here and
is
try to
light?
pretend you know what it is, you don't. It's intrinsically electromagnetic. In fact, what you call the photon
That's what
is
light
the
literally is.
Yeah, it's
What-
electromagnetic radiation. It has no.
Yes.
There's no photon that's not electric nor magnetic. So to claim that it's not affected by the
What?
electric nature of its environment is actually absurd.
Wait a
and
minute. Do you
asinine.
know what a photon is?
Yeah, a photon in reality is actually the oscillating magnetic field, the oscillating electric field, and where they intersect. It's an event or
Yes,
a process.
that's literally the definition of a photon in any QFT textbook.
No, you guys claim it's actually a massless particle. So you actually isolate it as if it has some
Okay,
type
so you
of
don't know how
physical
quantum
char-
field theory works. Got it. It's fine. It's fine. It's fine if you don't, because
That's
it's a
what I
topic,
said
but
earlier. Quantum
it's
field
fine.
theory. Quantum field theory is now just inching towards acknowledging an etheric framework.
Wait, you know that electromagnetic fields exist, right? Like we all acknowledge. Can we all acknowledge that they exist?
Yeah, can you prove
everywhere?
there's a little physical particle called a photon?
Hold on. Do you know what a quantum particle is?
Now, first of all, it's actually disagreed. So he's trying to give this illusory like he has it all figured out. So let's just go with the most popular explanation. I'm assuming you're appealing to consensus of quantum field theory. Well, then, yeah, they claim that the particles are just background excitations, so that everything is comprised of little background fields, and then you have oscillations or excitations that manifest themselves as quote-unquote particles, and we quantify them and give them names for quantification purposes. But it's that the excitation of the background fields.
Yeah, that's
right?
exactly it.
That's
exactly
right.
it.
Yeah, that's an ether model, but without acknowledging that there's an ether, because if there's an ether, then your entire heliocentric model immediately gets destroyed.
Wait a minute. An ether doesn't destroy a heliocentric
Yes,
model.
it does.
Yes,
No,
it does. Because
Yes,
all
it
of the
does.
motion
Elaborate.
of the Earth through the ether would be measurable. This
Yeah.
is what Michelson, Morley, and all
Hold
of
on.
these
That's
experiments
only
were
true if you reject special relativity. Do you guys reject special relativity?
Special
you're saying-
relativity specifically rejects any type of substantive ether. That's what it's. That's like its base postulate.
No. So okay, this is like a clear misunderstanding. I feel like I'm teaching. I feel like I'm giving a lecture right now. Like it's
You may be
very clear
convincing some
that
people
special
with that,
special relativity is like exactly compatible with electromagnetism, with the existence of an electromagnetic field, which you might call an ether. Fine, if you want to call an ether, fine. But special relativity was developed because electromagnetism was confusing and they didn't know how it worked. And it turns out that if you use this model of special relativity, everything clicks together. And then we go and test it and we observe that it is obviously observable.
All right, so like I've been talking a ton, so I want to let everyone else talk. So, and I think that we should maybe have a future conversation one-on-one or something, this is what you need to understand. So if the ether is substantive in quality, if it's substantive, it has a substantive quality, then in Michelson-Morley, we would have objectively had an impedance that caused a friend shift. And when we actually look at the evidence we now have in quantum physics, we know that there's a substantive background. We have free space impedance with dielectric permittivity and magnetic permeability. You get 377 ohms of free space impedance. So if a vacuum or free space has impedance, then that means that there's an ether with substantive quality causing that impedance. They cannot call it that. They cannot unify it and acknowledge the substantive ether because, again, if you have a substantive background, you would have got a fringe shift if the Earth orbits the sun. And this is all objective.
Can I respond or?
Yeah, of course.
Okay, yeah. So the whole business of the being able to detect an ether. Let's grant for a moment that the electromagnetic field exists. I think we all agree on that. That there exists some sort of electromagnetic field. I think we agree on that. Yeah.
Yeah, man.
Okay, so the electromagnetic field transforms in a particular way under space-time boosts, right? This is what special relativity is all about. And so in particular, it is what we might call invariant under these boosts. It doesn't change. And so you wouldn't be able to detect that even if you're moving through it. Even though, yes, it is like you can detect the electromagnetic field, it has this quality that makes it so when you are moving through it at any speed, it remains invariant. This is what's called a tensor, by the way. Like this is standard like first year grad school stuff.
Non
Like, this
sequitur.
is not. It's not. No. This is literally not a non sequitur. It explains why the Michelson.
I said free space
consistent.
impedance, and you brought up electromagnetic fields.
You're talking about the yes, because you're talking about the electromagnetic.
Hey,
field.
let's change it up a
No,
little bit so that there's not so much contention. I think it's not good for the audience. So what we'll do is we'll change it to
Yeah.
somebody on this side, Caleb or whoever wants to go first. You can have a minute to ask whatever one of them you wanted a question. When your question's done, then you have a minute to answer. You can respond for a minute, Caleb, and then they have a minute to close it out. So it should be 4 minutes for each person. We should be able to do this in a half hour if there's no craziness going on. So Caleb, go ahead. You choose who you want to ask a question. You have a minute. I've got a clock on the screen. We'll start.
I don't want to pick a specific person, but I
Okay,
would like
give
to
it to anybody
know
if you want.
what type of refraction is happening when we are seeing observations from over 273 miles away. Also, what type of refraction is happening when we're seeing mirror flashes from a 0-foot observer height over 40 miles. What type of refraction is happening with the Chicago skyline that is being refracted up into the horizon, supposedly on your guys' model. I just want to know how light, when you get into a denser medium, light bends down. So if we're looking over long distances and we're looking through a medium, the atmosphere, and it's most densest at the surface, we should all be able to tell from Derek's opener that light would bend down, not up. So I would like to hear specifically what type of refraction is happening when we're seeing these observations, these long distance photography observations from hundreds of miles all the time, as well as people from Chicago are seeing the Chicago skyline 4 or 5 times a week from 50 miles away. What type of refraction would you guys invoke?
So let me just address one point, and then anyone else can jump in.
We have a minute, so go ahead.
You answered your own question in your statement. The denser air, right, refracts light downward, right? You both said that, and Derek said that in his opener. And you showed a video of the sugar in the tank bending light downward. Now, you're confusing bending light downward with objects moving downward, but bending light downward actually makes the object appear higher, which is why, and yes, you can shake your head, however, okay, it's very simple, okay? An object with the light bending downward from where it is actually appears to make the object higher because the light is entering your eye on a downward angle.
You
So
know
the light,
No, he keeps going.
that's literally how refraction works. You can't really, I mean, light coming in, your eye sees it going that way up. So it raises the object up. Downward refraction raises an object up. That is just how it works.
Okay, so you got a minute to retort. Oops.
Do you know how eyesight works?
Yes.
Do you
I
know
just
like what
explained
you're
it to you.
actually seeing as the light reflecting off of a distant object? So the light from the sun has to come down at an angle, right? As it's coming down to reflect off of the object that you're looking at, it's moving through a more dense medium as it comes, boom, 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 and then it hits that object and it reflects over to you, which is what you see.
Right.
On its
Also-
way
okay.
over to you, it's bending downward. You
Okay.
cannot pretend like light bending downward somehow makes it appear higher in the air. Light, as it travels, moving downward, is going to appear lower. I don't know where this
Hold on,
idea.
it'll
In
appear
order
higher.
for
Wait,
it to
he's still
bend
going.
downward
It's our
into your
time.
20
eye,
seconds.
it would have to be up above your eyesight to drop down into your level of eyesight.
Let me
As-
say one thing.
Wait,
Let me
what
say
about
one
this?
thing.
Did
Derek.
you not?
And-
Keep going.
hold on, Globy. It's not your time. Not your time, buddy. So
ahead.
also,
10
I wanted
seconds.
to suggest that Globy is saying that downward refraction refracts things up.
Upwards.
Supposedly. This dude is literally contradicting himself in the exact same sentence. How is downward refraction
Okay,
refracting
time.
things up?
Time.
Yeah,
so they've got a minute to retort. Go ahead.
man.
Yeah, so I can answer that. I actually recently mentioned this in one of my videos responding to Nathan Oakley, but this is directly from the University of British Columbia. So during something called a temperature inversion, I think we should all be aware of what that is, right? We have a layer of cold air, and then, we have the inversion layer above it, another layer of cold air after the inversion layer, which is going to be hot. And again, like I said, this is directly from University of British Columbia. Light bends down towards the denser air, but because our eyes assume the light we see travels straight, the object we are seeing appears higher than it actually is. Again, just like Globy showed, if you draw that bent line, the way that we're seeing it, we just draw a tangent off of that. So that would be the exact answer. Light
Yeah.
bending towards the surface makes objects appear higher.
You can't see curved light, right? The light enters your eye straight, no matter where it's coming from, and hits the back of the retina. It's coming into your eye straight. So it assumes the object it's seeing from that light is straight ahead of it. Doesn't matter where the light's coming in. So if that light is bending down towards you, where it's entering your eye, you're going to draw a straight line from that, and that's where the object appears.
So a distant object that's the same eye level as you. Light hits that object, bends downward, and makes that object appear
Yes.
That's what they're saying.
Correct.
That's literally how eyes work. Can I show a picture?
Yeah.
Can you reference something that says otherwise?
Well, you guys are up next, so go ahead if you want to ask a question or you want to keep going on this topic.
Can't
Come
see
on.
it.
We don't
Yeah,
see
instead
that.
of making
I
a
know.
blur, change it to none.
All
yeah,
knows
I know.
you put
I
a
d-
pencil in water and it displaces down towards the more dense medium. It doesn't displace up.
Yeah, they're literally saying that it goes down, but it's seen up. It literally doesn't make sense what you guys are
Okay,
saying.
ignore the mess that is my house. Okay, let's say this is a building. This is you. Light's bending down to you, right? Yeah. Like we realize light bends down. You're looking at a building. 2 light rays come off, bends down to your eyes. So what does it look like? Well, it's entering your eyes at an angle, so it'll look like it came from higher. That's all Globy's saying.
Well, it's patently false. You can demonstrate without little cartoons.
This is just optics. This is just standard optics. My guy.
Demonstrate it then.
My guy, you can put a pencil in water and watch it be the denser medium below the pencil. The pencil will displace down towards the denser medium. Your cartoons don't change physical demonstrations.
Okay, Globe side, Globe, you can choose who you want to ask a question.
Can you
have a
show
minute.
us a physical demonstration?
They've got a minute. Go ahead, Globe.
Not with my hands, no. Like I don't have an experimental apparatus on me.
One
I'm
doesn't.
sorry.
Globe, go ahead.
What are we doing?
You get
yeah.
you have a minute.
So I mean maybe I just shouldn't harp on this, but like, how do you explain gravitational redshift in a laboratory?
That's your entire question. That's your whole minute.
I mean, I don't know. Do you guys have any other questions that you want to ask?
Nothing really in specific. No, I think that's probably a good topic to touch on.
Also, the Sagnac effect. That'd be.
Yeah, let's talk about the Sagnac
Let's talk
effect.
about that.
Yeah.
Let's talk about the Sagnac.
I like that.
Okay.
Yeah. So, what's the explanation? I mean, like whether you think it's an ether, whether you think that the Earth is whether you think there's an ether, or whether you agree with special relativity. In both cases, it shows motion. So.
So I don't think that the globe side realizes that the Sagnac effect is in direct controversy to the special relativity of light. The special relativity theory literally states that the observer's velocity is not added to the c constant, the speed of light. So if we're picking up a different speed based on turning a table, turning an apparatus is creating a fringe shift in the apparatus, that cannot be explained through special relativity, and it directly contradicts it. As well, if you were to invoke the Sagnac effect into like ring laser gyros, which use GPS, which assume the globe and assume all sorts of other things, you should be able to take that ring laser gyro to different latitudes on the globe and pick up a different fringe shift. We do not see this because the Earth is not spinning 1,000 miles per hour.
And
okay.
We still have
20
20
seconds.
seconds. And so as far as the Sagnac effect goes, you would also be able to pick up the Earth's rotation around the sun. It wouldn't only be limited to the rotation of the Earth. It would also be the orbit. But to add to what Caleb was saying, if the turntable is spinning and the light goes in one direction and they look in the other direction, if you go lower on the latitude line, the Earth would move slower and it would pick up a different fringe shift because the Earth is moving slower. The 15 degree per hour doesn't work when the fringe shift is based off of the speed of the light.
Go ahead. You got a minute. Globe side.
Yeah. So like, first, the Sagnac effect doesn't disprove special relativity. It is consistent with special relativity. Your understanding of it is flawed. It's not that the light speed is added, it's that the light travels a shorter distance. But that's neither here nor there. We can even reject special relativity if you want, and we can assume the ether theory for the Sagnac effect. You still see relative motion of the Earth through the ether. And what that means is that the Earth is moving. That's like whether you think it changes or not, like we observe motion, and that the burden is now on you to explain how that works. Because I've given a consistent model that makes it work. Both the ether, both an ether with a spinning sphere and an ether, and special relativity both explain this phenomenon. How does it work on a flat Earth?
You still have 20 seconds. Do you want to with us?
Sure. The moving it wouldn't change it because the Earth is rotating at 15 degrees per hour. You're talking about linear velocity, which that experiment is not measuring linear velocity. It's measuring rotational velocity. So you can shake your head, yes, but linear velocity, we don't measure rotations in linear velocity. So
you don't measure.
Oh wait, is the Earth's orbit not elliptical?
Go ahead, Globe. I mean, Globe 5. You have a minute.
Austin, if you want to say something.
Well, I just want to say I'll take like 20 seconds. The Earth's orbit is elliptical. It's not in a straight line. And of course, the Sagnac effect was really tested with Michelson, Gale, Pearson, and Michelson came out and said this verifies the ether and it perfectly matches our sidereal protection within 98%. And we know we have a sidereal rotation even on a stationary Earth around the Earth. So the real question is how come we didn't detect the orbit, but we detected the alleged rotation? And again, I just explained that you can't use linear velocity as a cop-out because it's actually elliptical, and they tested it up the entire year, and then Dayton Miller repeated it.
As well as the globe side is literally, hey, it's our time. Calm down. Impulse control, Globey. And literally these guys are assuming that the 15 degree that is picked up it just has to be the spin of this water ball that's spinning through space. When we have things like Mach's principle, there could be a translation of motion down to the ground through a sidereal rotation of the sky. Mach literally, Einstein admitted this in a letter to Ernst Mach in 1913. All of these guys have seen this information. They just act like they haven't.
No, let's talk about Mach's principle. Yeah. So let's do that. But by the way, so do we acknowledge that the Sagnac effect happens? That we observe a like a fringe shift? No, I'm not talking about laser ring gyros because they have quantum locking issues. But like you can do the apparatus and you can just do it without lasers, without any sort of locking. You can just do the apparatus and you will observe a fringe shift. Do we recognize that exists?
Yeah, there's a sidereal rotation. Yeah.
All right. So how does the rotation of the heavens affect that? Tell me.
Okay.
Let's hear about Mach's principle.
Yeah. So you first of all, you guys rebutted by saying the reason that Einstein on his deathbed said he didn't think it was true because he said that the lights are so far away that it wouldn't actually strongly affect it because it would have to be going faster than the speed of light to be spinning around a stationary Earth. Now, we don't believe in your stupid distances. We know that there seems to be a fluid-like medium. There's also a background medium which would transfer the motion down to a stationary Earth, and you'd get an effective centrifugal force with the mediums exchanging the interaction.
Okay, so where is this fluid-like medium? Sorry.
Okay, so for one, medium? Yeah, like seemingly in the sky, right? And secondly, we also have a background medium.
What is this background medium, and is it detectable?
Yeah, it is detectable. We have the Casimir effect. We have vacuum energy, 0-point energy. You guys call it quantum foam. We have
Casimir
dielectric
effect requires
permittivity.
special relativity.
We have dielectric. Nothing requires your theoretical interpretation. Nothing.
It
requires...
was predicted by special relativity, well, by QED in particular.
Okay, so
that is evidence of QED, by the way.
No, it's not. So we have, dude, taking the effect observed and then claiming that your interpretation of it somehow is required for the observation to happen is insane.
Okay,
so that's why we.
Well, let's stop there.
Dude.
We start a new minute. Whoever wants to take it, you take it this time, Austin. You get a minute to talk.
Sure.
Go ahead.
So
Make it
when
a
we look at
question.
a vacuum chamber, we have electromagnetic energy. We have the Casimir effect. We have 0-point energy, vacuum energy, quantum foam. There are many names for it. It is not just simply Newtonian emptiness. It has a substantive quality, and we have impedance of free space. So that is why there is a huge gap in current cosmology and quantum mechanics because it cannot explain the substantive quality and then also reconcile Michelson-Morley. So we know that there is a background medium. So then if we have an actual rotation over top of a stationary plane, it would transfer this energy and this motion or this interaction down through the medium, and we will be able to detect it on the Earth with sensitive equipment such as interferometry. So it's pretty simple, and we have tons of evidence for the ether. I can quote even like Frank Welczak, Nobel Prize winner in Your Own Paradigm. Everyone knows it. Everyone knows that there is a background medium that we observe inside of a vacuum chamber. It's not simply Newtonian emptiness. And that's what quantum field theory acknowledges as well.
Make it a question.
So if
You got
there
10
is
seconds.
a background medium, it would transfer this interaction down to the Earth. It's pretty simple.
And the light would be traveling on it, so it would change the speed of the light.
How does this motion transferred?
Through the medium.
By what mechanism? No, by what mechanism? Because we know how water transfers motion, for example. If you spin the middle of water, we know how that water transfers motion to the outside. By what mechanism is the motion transferred from the celestial sphere to the thing to the laser gyro or to the Sagnac apparatus?
Say I fill a bathtub up with water and I move my hand over the water and I can move the water without touching the water. How does that interaction happen?
Wait, is your hand in the water or you're not in the water?
No, it's just above the water.
It's just wind. It's just wind.
Wind. So how does it happen? Explain specifically how
you're bumping air molecules into the water molecules.
Okay, so there's an exchange. There's a molecular exchange from your hand down through the medium to the other medium.
Yeah. So you're bumping molecules into
question.
you're bumping molecules into other molecules. There are no molecules in this medium that you're describing. Doesn't have molecules. It's just a background field. How does it happen?
The atmosphere isn't made of particles.
No, we're not talking about the atmosphere here because presumably you don't think that the air is what's transferring this motion.
Well, actually, it would all play a role. So whatever the medium of space is, whatever the air is, the fluid-like nature of both of them, and the background medium would all be transferring this energy. But you're saying that energy couldn't transfer through the background medium. Then how do we have the electromagnetic fluctuations inside of a vacuum? We see energy transferred in a vacuum consistently.
What we don't see what basically you're alluding to, which is frame dragging. That's not a thing in quantum electrodynamics. It's not a thing in quantum chromodynamics or any sort of quantum field theory for that matter. Frame dragging is what you need in order to have induced rotation from an outside medium.
Okay, so you're talking about isolating a very small scale and claiming that the overall effect that we detect with ring laser gyros don't happen. I could ask you the same thing. How come that we don't detect the rotation of the Earth on quantum electrodynamics scale?
Hold on, I didn't make the claim that we don't.
Why can we not detect the alleged rotation of the Earth on the quantum scale?
I don't even know if that's true, that we can't.
No, we definitely can't. And so the point is that I'm positive. So that's the whole point.
That's a claim.
Well, you just made the claim. You made the claim that it wouldn't work because you can't detect it, but you can't detect your idea of
No, I
cellular
didn't. I
rotation
didn't make the claim that it doesn't work because you can't detect it. I'm making the claim that it can't work because you haven't provided a mechanism to explain how it works.
It's a simple exchange of energy through a medium like we observe
Okay,
in all
so
physical
how is that
reality.
medium exchanging energy?
Okay, we'll
How
go
are
back
you
and
getting a
forth.
frame dragging effect?
We'll go back and forth on that forever. So, Globe side, you got a minute to ask a question. Whoever wants to ask, go ahead. You have a minute.
To move on to a different topic. I mean, kind of in the same field, but something different. In my opener, I had mentioned the pressure gradient, which, if you guys remember, I had discussed that, within a container or not, the only way we're going to observe this kind of gradient, especially on a flat Earth, is either A, you would have to accept gravity, which unfortunately would mean the flat Earth would coalesce into a ball, or B, you would have to say that the Earth is accelerating upwards at a rate of 9.8 meters per second squared. Obviously, you guys don't like those answers. I'm at least pretty sure that you're not okay with those answers. But with gravity, we can predict exactly this. The actual weight of the atmosphere above you, you can think of it almost like a column, is going to be causing the actual pressure. And again, that's something that we predict with gravity. So I guess I would want to know where are you guys deriving this 9.8 meters per second squared acceleration from, and why is it consistent, between every single object we drop, for example, in a vacuum when no other forces are acting upon it?
If I can, guys. So to have a gradient at all, you have to have a container. So that's what we're invoking. Both our model has a container for the oceans, which water necessitates a container, as well as atmospheric pressure, atmospheric gases. They would also necessitate a container. So there is a container and there is a gradient to that container in the atmosphere. So we could ask you the exact same thing. We could ask you, how could you prove that you have atmospheric pressure when air pressure is literally measured by the exhortation on the actual container? That's how we measure air pressure. As well as you literally have to, like, when you're thinking of your guys' model, it's the atmosphere sitting right next to a vacuum of space, and they say that it's slowly getting away, it's slowly drifting out into space, the particles are going out into space slowly, but there is no mechanism to prove that they would go slow. If you can't replicate it at the surface of the Earth where gravity is supposedly strongest, you definitely cannot replicate it or invoke it that it's happening at the top of the atmosphere.
Okay, you got so who asked that question? Globes asked it.
Yeah, that was me that asked it.
Okay, and then you guys. So go ahead. You have a minute. Globe man.
Yeah. So, like I said, if we were inside of a container, what we would expect is that gas pressure is going to. Again, this is if we don't have gravity acting upon it, unless you have another force that you could say. Whether we're in a container or not, again, the only way we're going to be able to figure that out, or that we're going to get that gradient, is because of a downwards acceleration. On a flat Earth, what we would predict is that because of diffusion, the gas molecules are going to spread out evenly, and you guys have not defined a force that could pull it down at that rate. That's really all it comes down to. And unless you guys have something that we could, replace it with that is probable and testable, then I don't see any reason that we should have to accept that flat Earth has any way to explain it. Blitz or Globey, if you guys wanted to add something, go ahead.
Yeah, so the whole notion that, like, you can't have a gradient outside of a container, I just asked the question. There are continuous regions of water, right? Like, you can draw a line all the way around either the flat Earth or all the way around the globe Earth, and there will be places where you can make a complete loop of water, right? Where's the container for the water? It doesn't have walls on all sides, right? Because you can make a complete loop, and yet we still see a pressure gradient.
Yeah, the ocean floor.
Okay.
Wait,
the
so
ocean
but
floor as well as the
the ground,
Antarctic wall is
the
containing.
ground.
It's our time. It's our time.
Go
Yeah,
ahead.
start our minute.
You're good.
So the ocean floor is acting as a container, as well as the Antarctic wall that encompasses all of the Earth is acting as a container as well. So invoking that the center of the oceans doesn't have a container, it's connected to the outside of the oceans that is directly touching the Antarctic wall, as well as the bottom of the oceans is contained by the bottom of the ocean. So again, when we're talking about this, we have to realize that you cannot invoke anything. You can't show me air pressure. You can't show me gases staying at a gradient without a container, other than when Globey invokes the atmosphere, which is in question, which is a reification fallacy. It happens constantly when we bring this up. So I would like one experiment to prove that we can have atmospheric or gas pressure without a container. Can I get one experiment, and Derek take up the rest of the time?
Well, and also you guys saying that if gravity was a real thing on the flat Earth, it would crush the flat Earth into a ball. That's a straw man argument. based off of the assumption that gravity pulls everything to the center. Ours is it's a downward vector generated by the electrostatics of the atmosphere. So for you to say that it would crush us into a ball and it's not possible to have this downward vector without this magical gravity, you're totally leading people in the.
Go ahead. You guys got a minute now?
What's the physical barrier on top of the ocean?
Are you asking why water has a level surface?
Question?
Are you asking why water has a level surface?
No, I'm not asking why it's level. You said the water is contained on all sides. What's containing the what? You said a physical barrier needs to be on top of the water to have water pressure.
Okay, you have a whole minute. Hold on. Give them a whole minute to answer or to ask a question.
You said a physical barrier needs to be on top of the water to have pressure. Water has a lot of pressure. So what's containing it? I know, yeah, it has sides. Sure, we'll agree it has sides. What's on top of it?
To be clear, the Earth also, the atmosphere is also contained on the bottom by the ground, right? Like so if you can use the bottom of the ocean to contain the water in the ocean, then why can't we use the bottom of the ground, the surface of the water, the surface of the Earth, to contain the air in our model, right?
You need
sides.
sides.
Seems like we should be able to do that.
Well, you said it needs to have a container. So explain what the container is of the water. Why is the surface of the water? Why isn't the high pressure of the water bursting out of the top of the water?
I'd also like to know what you guys think a container is in the remaining 3 seconds that we have. So if you guys could address that as well, that'd be great.
So what do you guys understand? You know that's not analogous at all. The water's more dense than the air, but the vacuum is less dense than the air.
Yeah.
Do you understand? It's not analogous.
We do understand. Thank you for admitting it.
So that's a very dumb. That's a very.
That is
dumb
what causes
question.
air pressure. So
Okay,
thank you
keep
for
it up
admitting
over there.
that's the atmosphere.
Not your
Flat
time.
side, go.
Yeah, impulse control, not your time. So
Casey,
yeah, asking.
Casey.
Hey, impulse
Stop
control,
with
not
the
your time,
nuts.
bro.
Stop with
Not
the
your time.
nonsense.
Impulse
Your time,
control.
McFace.
Impulse control.
Stop,
Impulse
stop,
control.
stop.
We still have, can you restart our timer?
I will
for
start
us?
it. I will restart it.
15
No one has
seconds.
impulse controls except you.
Dude, you're still talking. What are you doing, Globy?
Everybody,
They're great.
Recorded, bud.
relax.
What are you doing?
Relax,
Calm down.
relax. Here we go. Minute for you guys. Flat. Go ahead. Answer that question on the container.
Okay, so Globy went and invoked, where is the container on top of the ocean's water? There's atmospheric pressure and it's densest at the bottom, which is pushing down on the water. And it's more dense than the molecules that are oxygen and nitrogen and these other molecules that make up our atmosphere. So that's why things go down in the medium of the air. So if you're more dense than nitrogen, oxygen, and other molecules, you're going to go down. Now you're going to say, what decides the downward vector? And Globeman has constantly reiterated this. You don't have a medium. You don't have a force. Electrostatics, there's 100 volts per meter. There's plenty of Richard Feynman lectures that explain this, that as you go up into the atmosphere, 100 volts per meter, there's an electrostatic charge that is constantly seeking down. And I know that you forgot and you act like you don't know that the Earth's surface is negatively charged at about 500,000 coulombs. So if there's positive charge in the air and the Earth's surface is negatively charged, the atmosphere is going to seek the ground, creating the vector.
Time. Hold on.
Cite that, please.
It's
I'll drop it in the chat.
Flat Earth term.
Cite a net downward vector from what you just said.
I'd also like to ask why is it that hold on, this is our time.
Not common sense.
I believe it's
time.
Flat Earth's time
Impulse
to ask the
control,
question.
Caleb. Impulse control.
Their timer.
So
It's our time.
So
Is there time?
I'm glad that Witsit acknowledged that heavier things don't need a container above them if there's something less dense above them. Like the vacuum is less dense than the air, so of course it doesn't need a container above it. I'm glad that Witsit admitted that. I'm glad that we can agree that the air doesn't need an upwards container to make that work. Also, I'd like to keep in mind that the downward pressure from the air isn't a container in the sense that you guys refer to. When you guys talk about containers, you're talking about a water bottle, you're talking about a glass box. But a downward pressure isn't that. So you still need to explain how it is that water has a pressure that's obviously pointing up, and yet somehow still the air pressure keeps it down. That all that says to me is that a container is just a force keeping it in, and we can provide a force keeping the air in. So why do you accept this downward pressure from air, but not the downward force of gravity? I know, because you reject gravity.
Is that,
anybody else
is that a question?
You can.
Yeah, sure. We all know air pressure almost reduces to a vacuum, right? Do you guys disagree air pressure decreases with altitude?
No, of course not. So you guys claim that the gradient is impossible on a contained environment. That sounds insane to me. So you can replicate all of this. You can go to a lab, have a container, put gas in it, introduce gas constantly at the surface like we have on the Earth. Gas is constantly cycling, being introduced from the surface. In fact, the vast majority of our gas comes from underneath the surface. And then we could introduce a downward electric current inside that vacuum. And we are 100% going to maintain a gradient with or without the electric current. The electric current maintains it with more stability. So we can prove it. And when I brought it up as to the differences between the ocean, it's obvious, I assumed, but of course you have a fluid medium as with air above it. These like water and air are not the same. The density distribution relative to those two things are completely different. That's an insane question. And of course, I dropped Richard Feynman lectures 9 section 1, chapter 9 section 1, explaining the exact downward electric current that they invoked. Since you asked for a source, there it is. And so again, we can replicate that in a contained environment. You could have a gradient, certainly with gas introduced at the surface with a downward electric current on top of it, keeping that stable. So the question is, what do you guys have that keeps that from dispersing into the infinite available space?
We've told you it's gravity. Also, if the Earth is negatively charged, which I believe it is, I don't think it's positively charged. If the Earth is negatively charged and it's not gravity but electrostatics that keeps things down, why is it that you can charge like an iron ball, give it just a little bit of negative charge, and it doesn't fall up?
You can make things float with charge.
Yeah, but hold on. If it wasn't mass, if it was just charge, then the mass of the lead ball, the mass of the iron ball wouldn't matter at all. All that would matter is the amount of charge. So you could just put just a teensy amount of negative charge and it would float up. Why does it still go down?
No. Mass is intrinsically electrostatic. So is density. So is weight.
Prove it.
So
prove it. What is the electric field around a neutral atom?
Prove it. All molecular and intermolecular attractive forces are electrostatic.
Yeah, they're covalent. They're covalent. What is the so in a metal, because metals aren't covalent bonds nor are they ionic. In a metal, what is the electric field around a neutral atom?
It's not about electric field around it. First of all, there is no such thing as neutral charge, right? Like you can try to attain neutral, but there's constant flux.
Net neutral, fine.
There's no such thing as net zero. There's no such thing.
What is the electric field around a net neutral atom?
There's no such thing.
An atom with the same number of electrons as protons. What is the electric field around it?
There's no such thing as net neutral.
Yes, there are. Yes, there are. This is the thing that we can make all the time. Net neutral atoms are the most common type of atoms.
There's no such thing.
What is the electric field? Wait, so you're just rejecting chemistry too? Because this is you know that chemistry is when like standard chemistry is that atoms in their natural state.
Okay, time. We got
the same number of electrons as protons.
Flat side, you get to take a minute. I guess mostly Derek. I think we're on Derek. Derek, go ahead, take a minute.
You're good.
Well, first of all, to just address a claim that they had earlier, talking about how we need to prove that these things are moving. If you were to look up at the sun, the stars, the moon, and anything in the sky, it is in fact moving. It is the globe people's responsibility to prove that it is the ground that's moving and not the lights that are in the sky. This is one of the many ways that they try to mislead you and misdirect your attention into asking questions that shouldn't be asked. They should be answering these questions. To touch on the atmospheric pressure, it's measured in all directions. To pretend like the physical weight of the atmosphere or the atmosphere's pressure is the physical weight of this atmosphere being pulled to the ground, that is ridiculous, because you can measure the atmospheric pressure in any direction, down, up, sideways, left, right, diagonal, however, and the globe people they're not going to argue that when you put 30 pounds of pressure into a tire, that tire's not going to weigh 30 pounds more. But then they will turn right around and claim that's the 13.7 psi that we all experience as our air is somehow magically the downward pull of the atmosphere, but it's measurable in all directions. Makes perfect sense.
Was that a question?
That wasn't a question.
Okay. It's just a rebuttal.
I guess you guys can say whatever you want, Globes.
Answered.
You have a minute to answer whatever that was. Go ahead.
Sure, the atmosphere, 14 psi of the atmosphere doesn't pull us down, so I don't know why you said that.
Yeah, because that's something that I had talked about before. Again, the pressure, again, if you look at the barometric formula, it's derived from the principle that the air above us is going to be what's causing the weight. So I don't see how we're going to claim that it's something else, such as the gas bouncing off of a physical container. It doesn't make sense. I mean, again, like I said, I showed the formula originally in my opener. I can pull it up again if we wanted to see it, but it does require gravity. Little g, right? A downwards acceleration of 9.8 meters per second squared. And if you're going to invoke electrostatics, I just wanted to ask, wouldn't that mean that paramagnetic, diamagnetic, ferromagnetic objects would fall at different rates? Why would we expect them to fall at the exact same rate if it truly was that instead? I'm a little confused about that.
That's magnetism, not electrostatics. But one thing to add is that charge distribution, and thus the electric field around a neutral atom is 0.
Okay,
well, the
time-
charge distribution is symmetric, so the electric field is 0.
You don't have to. You can ask a question or whatever, Derek. You go ahead.
So I'm curious then, if gravity is 9.8 meters per second squared acceleration rate, but the strength of gravity near the surface versus up higher is negligible, what causes objects to accelerate at a certain speed, and why don't objects that are orbiting the Earth because of gravity, why don't they keep accelerating? You're going to tell me that a rocket ship can gain its speed by orbiting the Earth a few times to get up to its speed. Why does it stop accelerating? What force stops this object from increasing its speed as it's orbiting around the Earth? If it's orbiting around the Earth because of gravity, and gravity is an acceleration rate, and it's negligible in between the surface of the ground, 5-10 miles up. Sure, I think it's like 12% difference where the ISS is, but it's not increasing its speed. It's maintaining a 17,500 mile an hour orbit, but it's acted on by gravity. How does that work?
Oh, and the last 15 seconds, so actually there's no such thing as net neutral. It's in constant flux. You just consistently saying it means nothing. It's in constant flux, just like there's no such thing as a neutral surface charge. It's in constant flux. That's why we ground things. We try to get it neutral, but it's constantly in flux and changing. That's just objective.
Sorry, no,
Okay,
no,
you
this is just this is just false. Like neutral atoms exist all the time. We do chemistry on them. We do experiments on them in the laboratory. But this is just another. This is a funny point that you bring up, Derek, because the reason things orbit is because of the acceleration downwards. When you have something moving this way and there's an acceleration this way, it causes their velocity to point in a different direction. And because they're moving, their velocity bends at the exact same rate that they need to go around in a circle. That acceleration makes the orbit happen. It doesn't change their speed. They don't loop around the Earth to gain speed. They fire rockets to gain speed.
Can I respond?
I don't know. Well, we still have 25 seconds. Do you guys want to address that?
I don't know. I don't really think I have much to add to that.
So
That
you're
kinda hit it
telling
on
me
the head.
rockets don't
Wait, Derek.
go around
Let
the
them
Earth to
finish.
gain speed to fly to the moon?
Let them finish.
Yeah, but they burn their engines while they do that.
They shut their main off, like after like 3 minutes of takeoff.
Yeah, so they don't
We're not
gain
talking
speed
about-
while they're just going around.
Yes, you're talking about. There's a difference between orbiting Earth and using a planet as a slingshot to gain velocity. That's two different things.
And
So-
by the
So
way,
how-
both require
Hold on,
orbital burns.
Is it our turn or their turn?
It's really
go
we
ahead.
went through.
You
I
can
think
answer
everybody,
both,
so we can go to the questions from the chat, or we can do another round of that if you want.
We do have 2
I have a
minutes till
question.
11. Maybe are you guys okay swapping to chat questions? Is this unless anybody wants to close anything off?
Yeah, I would like to. I don't think I ever asked a question. I would like to ask.
Okay, yeah, let Gleb go. Or
I
McFace,
like this
or-
simple one here. I'm going to share my screen real quick. Oh, not this one. That's terrible. Okay, I'd like to hear your guys' excuses for these flights that fly direct from Johannesburg to Sydney. They fly 3 to 4 times a week. They are there's one's in the air right now. They fly it's 12 hours about, I think. Yeah, about 12 hours and 9 minutes is what's expected. These are all the prior ones. You see they're all about 12 hours. What else? So so the point of that is the distance they fly, which is in here somewhere. Where are you? I got to click on one of these. Hold on. This will tell me the flight. Okay, so
I think if you scroll up.
Where is it? No, it's in here somewhere. Is it here?
Okay, so your
It's on the
questions-
right, on the right side.
All right, I'm used to on Android. It's underneath.
Yeah.
Yeah. All right. So 556 miles per hour is what the flight flew, and it was about 7,000 miles.
Okay.
Now, this is directly relatable to, say, this flight, which is American Airlines 52, which also flies all the time, about 7,000 miles, about 560 miles per hour, and about 12 hours.
All right, we got it. Thank you, guys. Flat, go ahead. You have a minute
Go
to
ahead.
answer. You get another
Now,
minute in a second, Globby.
Yeah. Okay. So, like, yeah, of course, we actually see that the flight times are different drastically in each direction. So, the original flight and the return flight are completely different, up to 3-4 hour differences. They admittedly catch the jet streams. We have recorded in the northern hemisphere that you can record a ground speed of a plane over 850 miles per hour, and that's where the jet streams aren't even as fast. And this is openly admitted. Of course. So, like, in your own paradigm, we know that you would have the static pressure around the plane giving you an airspeed reading of 500 or 600 miles per hour. And in fact, you could be going 800, 900 miles per hour. And they admit that they catch the actual jet stream. And they admit that it takes up to 3 to 4 hours difference on the return flight than the actual original flight. So, of course, when they happen to fly right over the jet streams and they happen to go faster right when they fly with the jet streams, and then we happen to know that they can go up to 900 miles per hour, that explains a lot of it. Plus, of course, the southern distances seem to actually be incorrect.
Okay, you have a minute?
Yeah, airspeed is measured with pressure. So the recorded airspeeds are all there for you to see. So you're saying those are all incorrect.
No, he's saying airspeed and ground speed are different.
Yeah.
So the airspeed is 600 miles per hour. That is measured from the relative to the ground.
No, it's relative to the static pressure around the plane.
Yeah.
Wrong.
Okay. So they're flying 1,200 miles per hour, really relative. To
I mean, so isn't the claim that, like, on a flat Earth that would be like 2 or 3 times the distance? No.
Right, yeah, that's what I was going to say as well, because we're seeing, again, if you're looking at the normal flat Earth model that's shown the azimuthal equidistant projection, those distances, if you were to draw them for those flights in the northern hemisphere, would be much, much shorter. Like, the line itself would be much, much shorter. But in the southern hemisphere, going directly from what was it? Was it Johannesburg to
to Sydney?
Yeah, so Johannesburg to Sydney, that line would be incredibly long.
Like we're not talking a few hours.
Yeah, and we can see by the direct flight, it's not flying over the United States or anything. It is staying over the Pacific.
Yeah, well, this isn't a few hours. This would be like double the time.
Well,
Okay,
everybody
time.
knows that
Time.
maps are not accurate.
Go ahead.
Right? So we can't. Why are we going to sit here and pretend as if these maps that you already reject are accurate enough for you to debunk something that you're already rejecting? If you're going to take the map and invoke it as proof of your thing, you're going to have to accept that the map isn't accurate and that your distances could be slightly off, and that would alter what you're considering a longer flight if the grounds were in different positions.
The distance is measured. The distance is measured.
Hold on. You got flat side. You have 35 more seconds. Is that your answer?
Yeah, okay. First of all, airspeed and ground speed are different. That's incredibly insane that you didn't know that. Use static pressure relative to the plane. Ground speed is completely different. When we measure ground speed in the north, with our jet streams are slower. Then we get up to 850 miles per hour. You could easily be going 600, have 250. You'd have 850. You could go further than that, up to 900. And the southern distances have been proven to be incorrect. Every single time people actually navigate closer to the 55 or 50 degrees south latitude or further, the distances are completely incorrect. So it would be a little bit closer. You'd catch a jet stream. And it all works perfectly on a plane Earth, which is how you have to fly the plane.
Do you have citations showing jet streams making a plane fly 1,200 miles per hour? And also, do you have citations saying that the distances are incorrect in the southern hemisphere as measured?
Yeah, I have tons of citations explaining that. Tons of mariners and
you made two very specific claims.
So I just want to interrupt here. We are over the 2 hour mark. Do we want to change to questions?
We should, but let's finish this off. Globy, you have 45 seconds to finish your questions here.
Yeah, I would just like to see the proof that distances are not correct in the southern hemisphere, because that's a positive claim that can't be supported.
Is that it?
And jet streams. I just said it. How are jet streams? Show us the speeds of the jet streams in the southern hemisphere that are magically carrying a plane double the speed it needs to go one way, but not affecting the return flight, because it's the same flight time about.
Because that would require those the wind direction to change for the return flight, which that wouldn't be able to be explained. If it's going one way and you're saying that's what's allowing them to get that speed, you're saying that the wind that would normally be going that way suddenly has to go the other direction only for that return flight to again go back the other direction again once they fly that path back the other way.
Final minute for the flat side. You have 1 minute.
Yeah, I'm just going to add something for 20 seconds, then Austin, you can jump in. But if you literally map the wind projection of the Earth over an azimuthal projection, you'll see towards the Antarctic wall, it goes around clockwise, and then you'll see there's a layer that's closer to the northern hemisphere plane that goes the opposite way. So when they're going back, they're catching the inner one. When they're going out, they're catching the outer one. It's actually extremely simple. And they admit that these go up to like 250 to 300 kilometers per hour. So you guys can take up the rest of the 30 seconds.
Yeah, of course. Like planes are engineered to optimize the actual impedance of the air, so it's going to immediately react to the actual airspeed. So if it's trying to go through a jet stream, when it's going with the jet stream, it's going to maximize it by getting in the middle. It's going to avoid that jet stream on the path back, and this is actually built into the engineering of the plane and the computer systems. And of course, you're wrong; they are not the same time back and forth. They're drastically different, and it's been documented numerous times that there are up to 3 and 4 hour differences between that specific flight that you brought up. So that isn't true. They have to go further north. It is a fact. It's easily verifiable.
All right. Nice job, guys. You got through that. That was good. All right. So I'm going to bring up the super chats. Remember, Caleb, one more time, tell people where the donations are going and how much they need to be.
So they need to be $10 or up. So if you have any questions and you did send them in with $10 donation, you can just explain like who you want the question to go to. We will read it off. Half of the donations will go to Paul from our side, and then the other half will go to whoever the Globers decided. Truth by Science, or I can't remember.
Yeah, I think it's at Truth by Science or at Truth by Science. It's Dean.
Yep. So really awesome. I'm glad that even though it got a little bit heated, I'm glad that we did some good with this debate. I'm glad that the donations will be going somewhere good, and nobody should have a problem with that. So yeah, let's start going over the questions.
Awesome. And we got a good amount of viewers, to 1643. And that's a record for me. We'll take it.
Nice.
Good stuff. Good stuff. All right. So we're going to start with the questions here. And again, $10 or over, and those are all getting donated. So let me bring this up. And hopefully it tells us who they're aiming it at, or else we'll just have somebody from that side to have to pick it up.
Yep.
So starting with this one, we've got, thank you very much from Charlie, but no question, $20 for that one. We've got another, Kayla, thank you for the $9.99, but no question for that one. $20 from John, no question. $50 says, let's get it, guys. Cheers to the True Earth boys holding it down. Much love to Paul and the Tinfoil Hat family from Beer and Bratwurst. Thank you, Rhino. $20. What is the Globey side #1 go-to globe proof? That's from Melodome. Should I put a time clock on that, or what do you think? Or just let you go?
Yeah, do like a 1 minute.
Okay,
or
we'll do a
1 minute
That
30
keeps it
and
good.
let them answer it. Yeah, sure.
It's the whole side. You guys have a minute to go ahead and answer that.
Yeah. Give them a minute.
I usually like sunsets. Sunsets are pretty good for me. They're simple, but we could talk about that for hours, I'm sure.
Yeah, sunsets are good, right? They set in the southern hemisphere plane. They set to the left, right? And on the equator, they set vertically. And in the northern hemisphere, they set to the right. That is only possible on a globe. It certainly is not possible on a flat Earth. It would always be circling to the right. Doesn't matter if you're outside, south of it, or north of it. It would always be going towards your right. It would set relative to the ground. It would set left to right because it's always circling to the right.
And then for me, I would say it's probably the experiment that Globey did, the Southern Cross experiment. I think it was demonstrated pretty well here today that the bendy light alibi does not suffice. It does not work. The flat Earth is not able to explain how light would follow that path. But on a globe, it works perfectly. It's been shown in AutoCAD, multiple different things, that the observations make perfect sense when we put things to the same scale.
Just a question. Are we going to be doing a thing where each side, like the other side rebuts, or are we just going to just do one side answers?
No, it should just be
It
question.
depends. How many questions do we have, Jaron? Do we have a lot or?
Not many. Not.
Oh, really? Okay.
Okay. Then yeah, I think we should do 1 minute, 1 minute, if that's cool. I think that'd be good for the audience. So, if you want to start our timer, Jaron, what we just heard is the best proof that we're on a spinning water ball is to look at the sky, to look at what's going on in the sky. That's just at its base logically fallacious. And yeah, I'll let you guys take out the rest of the time.
Well, and I've got a quick clip here of sunsets on a flat Earth on how it would work. As far as the sun setting in different spots, if you're outside of the sun's path, it's going to move from your looking towards the north. It's going to move in a different direction, just apparently, not physically. But I'm going to go ahead and share my screen with you real quick. We're going to play a quick little clip.
Oh, you're pulling that up? Yeah, so when Globey made his video about sunsets going right and left and straight over your head, that's when the sun is right straight over your head, when it's going over the equator straight over your head. And if you're more on a more southern declination, you're going to see it to a left and go as an arc, because we talked about, we see it in an azimuthal grid of vision. And the same is for when you're more north towards the North Pole.
Exactly.
Very easily explained.
Very easily. It's a perspective issue. Now, if you want to look at the screen, this candle here is attached to a RC car.
That is super loud.
Yeah, this is bad music there. Turn that off.
All right, we'll just leave the sound off. But as you
Yeah.
can see, this candle is acting as the sun. It's moving further away from the observer. As it goes down, it drops out of view without physically getting any lower. Our atmosphere does act as a lens, as it does have water inside of the atmosphere. It's got molecules. It's got all kinds of different refraction properties. So when you are looking at the sunset as it gets further away, not only, I'm not sure if it's in this clip or not, but it also doesn't shrink if you add a lens. If you move it away without a lens, it shrinks more than if you move it away with the lens. The shrinking affects the lens acts, the atmosphere acts as a lens, and it magnifies it, and it makes it appear to lower, makes it appear to rise. It's not a physical
So
thing.
can I
Next
respond
question.
to that, or we got more?
Go ahead, be quick.
Okay, so now if that candle was circling to the right, would it ever appear to set to your left?
If you're
While looking
down
at the
south of it,
sunset, while looking
you're
at the
down
sunset.
south of it.
I'm not talking about which way the sun travels in the sky. Yes, if you're south of it, it would travel from your right to left. I'm talking about while you're watching the sunset and it's going out of your vision and it's setting.
If you're south of the sun and you're looking towards the sun, the
Yeah.
sun's going to move from your right to your left. If you're north of the sun, then it's going to move from your left to your right.
The sun is physically moving to the right at all times. It cannot be setting to the left.
It's you. Hey, Globy, you remember your video of the your shadows on the moon?
Here we
Yeah.
go. Watch.
Apply that.
Here. I'm south of this fan. At what point does a fan blade ever appear to go to my left? Well, it might
It's
be
currently
backwards on
moving
your
to your
screen.
left right now.
Well,
on
the
our
screen. Sorry,
Not when it's moving away. That's the
So if
important
you were
point.
at the center of it, looking toward down the blades, it would change its apparent location. Versus
Yeah.
if you're outside of it,
we
looking
we
down
we
the
should get off this topic. We should move to
Yeah, let's
questions.
go to the
by
next
way.
question.
Yeah,
Uh,
let's go to
it-
the next question. We can't do that.
Yeah,
anymore.
summarize all the
is there
globe.
any way I
It
could add one
hijacks
thing?
perspective. We can move on.
Okay,
I was just gonna say, could I just add one thing? I promise it'll be quick. It's just with what Derek showed. Again, according to Snell's law, light bends towards the more dense medium. In a Fresnel lens, the more dense medium is going to be in the center. So you've just proved that if we have the more dense medium above and we move something away, if the light bends upwards, then it's going to appear lower. So that debunked your claim from earlier, where you said light bends downwards, making things appear lower. You just demonstrated that that was false.
You saw the candle drop below your line of sight. It didn't. The
Okay.
bending of the light did not make the candle appear above the lens. It actually made it appear below it, right? So,
Because the light
contrary
bent
to
towards the more dense medium,
the
which
light
made it
bent
appear lower.
downward, which made it out of your view.
All right, let's go to the next one. Next one.
Was
We've
that-
got-
sorry, that was it. That was all I
next
had to
one.
say.
Next one. For
let's go
everyone, so each person with a minute, or each side with a minute, explain how Occam's razor favors your side. That's from Frequencies Illuminating. Go ahead. Let's start with the globe side.
Sure. Oh, I love it. Well, I kind of showed it earlier, right? So does it make more sense that light is magically bending 180 degrees from all locations all over the world, looking south? You happen to see all the same stars from one continent as the other at the exact same time. Does it make more sense that you're seeing all that light bending around? There's only one point of celestial rotation, but that has to happen everywhere at the same exact time on flat Earth for that to be valid. Or is everybody just looking south?
In addition to that, the level of from a sociological perspective, it's not just NASA that would have to be lying. It would have to be every physicist, basically, for the last 150 years, who is either incorrect or lying. Just by sheer numbers alone, it's highly improbable.
And then for the last 10 seconds, I'll say because Flat Earth is not able to make any predictions that match what we see in real life, like I demonstrated in my opener.
Well, I would just like to point out that everybody is taking observations and the math from those observations to do their data. And those observations and the math that follows are identical, regardless of whether or not it's the Earth that is moving or the stars that are moving. On our model, we are not suggesting that the apparent motion of the sun is happening because we're moving. We're taking an actual observation and we're applying it to our model. I would like for Whitsitt to show his diagram of the Southern Cross stars being viewed from the globe and how they are actually in different directions despite the globe people's claim. I think that'd be a good way to end this. And Occam's razor favors the flat Earth way more than the globe because the globe has to assume distances and all of these different things that can't be proven. And
You're gonna be out of time pretty quick here.
That's Occam's razor.
Yeah. So Occam's razor. So we go outside, we don't feel the earth moving. We see the sky rotating above us. We don't feel any motion. We can't see any curvature. Again, if you use Occam's razor, just with the thought of the selenilian eclipses, we are actually seeing the sun and the moon. It's not just this magical looming effect that's happening. Occam's razor completely favors the flat earth, nothing to the globe earth.
Okay, time. Let's go with the next one is the picture Whitsitt used a 360-degree view picture when showing both ends of the crepuscular rays curving. There is no way in reality to take a normal picture of both ends, and the rays don't actually bend. That's from Flat Earth Denier. I don't know. Is that a question? I guess so.
Yeah, it just seemed more like a statement.
Like an accusation.
It 100% wasn't a 360-degree view. I guess you don't even know how cameras work and what they look like. We have many different observations of this, and the point that the globe earthers can never respond to is how come if you go from a optical convergence point on the west where the sun actually is, and you have another one 180 degrees, and you guys claim they're parallel rays like railroad tracks in each direction, and they're going over our head. If I draw from the first point over my head to the second point, how could you do that without getting a curve? How can we observe them directly curved? How can we observe them without wide angle lens curved? How do we observe moon halos, sun halos, etc.? We know that optics causes optical convergence 180 degrees away from the actual source, and that it causes a curve. And the globe must acknowledge this, that perspective causes this. It's just a fact.
That light from the sun is actually traveling to those two locations. Wouldn't you agree? The sunset is shining the light over your head to the other side of you.
What's different about a star?
Because a star is shining light at you. You're saying that the light from a star you're looking at shining at you is somehow bending 90 degrees to the right. It's a completely different phenomenon.
No, it's not. No, it's not.
It is.
The anti-crepusculars explains the
that's good. We're done with that
southern
one.
convergence. You guys don't understand the argument yet, but
We have to be good about answering.
Thank you,
super chats.
Joshua
They pay money
Kelly.
for it.
Yeah, thank you, Joshua Kelly, for $20. No question. We've got $10 from Michael Media or Mikhail Media. He says, "Is 8 inches per mile squared correct or incorrect, and why?" I guess we'll give both sides that opportunity. Go ahead. Flat.
That's definitely for us, by the way.
Okay, you go first. Cool.
Oh, I mean, it's a good approximation. It fails at, depending on what degree of accuracy you need it to be accurate at. It fails at a certain distance, like 50 miles. It'll start to be off by like a foot or something like that. At a scale of like you can do the math on this. It isn't the exact formula, but it's a fairly good approximation over small distances.
The main issue with it is that, first of all, it doesn't assume an observer height, and second of all, it's not going to assume any refraction, which obviously we're looking through the atmosphere. Refraction exists. We never have a point where we have absolute zero refraction while looking through the atmosphere, which the 8 inches per mile squared assumes.
By the way, that 8 inches per mile squared is dropped from a tangent, right? So you have a straight line going off from your sphere. This is measuring the distance between some point a distance away and that tangent line. That's what that 8 inches per mile squared measures. Now, again, it's an approximation. It's a parabolic approximation. The real thing is trigonometric, but it's a fairly good approximation.
Okay, we got Brian 17 says, "How can you prove a theory to be a fact like gravity?" ? I guess that's for the globe side. Begin.
Sure. Cavendish. It's a great example of an experiment.
But also theories don't become facts. This is never a thing. Theories stay theories. Theories are different from laws. Hypotheses become theories, sure. But facts, like theories, aren't in the same category of ideas as facts. Facts are just things that you see. Theories are explanations for things that you see. It's a different category of things.
Okay, good.
And that seems to be a big misconception. People believe that theory means just a guess or, simply a hypothesis, which isn't the case, right? When someone says that it's a scientific theory, such as, the germ theory of disease, atoms, plate tectonics, things like that. These are all based on a theoretical framework, but I don't understand why people are saying, well, that just is a guess, right? It's not a theory in the same way that one of your friends might think Obama, has a theory that Obama's a lizard person. They're not synonymous.
Or that his wife's a dude.
Yeah.
What's it? That sucks, man. That sucks.
Okay.
That's shitty.
Mike.
Let's go with the next one's from None of Your Business, who says, "To Globers from a flat Earth, what do you believe NASA lies about, or do you believe NASA is omnipotent and benevolent?" Go.
I mean, I don't know. I'm yet to see any proof that they lie. I've seen a lot of things that flat earthers show, such as videos where they've done a fade or transition into the next frame, and they're like, look, this is a CGI fail. I'm sure some of you guys have heard of the infamous pocket gate, right, where the dude's pinky gets stuck in the guy's pocket and everyone was saying it's wires. I've seen a lot of claims of people saying that it's fake, but nothing on the actual evidence side.
Yeah, nothing has ever held up to the scrutiny of, is it fake?
Yeah.
Right. There's a lot of claims of wires, but no one can ever point at a wire and say, there it is, right? I mean, there's claims that they exist, but there's no lying. There's the fake Earth images, the composites that they claim NASA lied about when they told us exactly what they did, and those were only for images from low Earth orbit satellites from a certain time period. Prior to that, there's many thousands of pictures of the Earth on film. From about 2002 to 2015, low Earth orbit satellites were using composite imagery because they weren't far enough away to take one full picture. Since 2015, we have satellites far enough away to, again, take full pictures. So
Okay.
You heard it first here, guys. The government would never lie to you, ever, especially for money.
MK,
that's a straw man. That's a straw man.
Can I invoke something just real quick?
No one said that.
They literally admit with the 1972 blue marble that they took satellite data, low Earth satellite data, which could have been balloons. They stitched it over a flat Earth map and then wrapped it around a ball. I can literally show you this citation.
That's not the 1972.
Go ahead, because that's
Brian
exactly
Simmons,
the one
Brian Simmons made. They admitted they mapped it over a flat map and wrapped it around a ball.
That's not
2072. Argue about the year. You're not addressing the claim that I'm making. Argue about the year. I don't care what year it was.
All right, let's move on.
Exactly
But
what
why
I
did
just
they
said.
make a flat Earth map and wrap it around a ball?
Okay,
From that time period is exactly what I said. That was a low Earth orbit composite from a satellite.
From 70 to 2015, right when Flat Earth came out. Gotcha.
Not from 70. Who said 70?
Well, yeah, hold on. So you guys are saying that it's Photoshop, but you guys fail to realize Photoshop wasn't even existing for another 20 years.
Nobody used the word
Hold on.
Photoshop but you. You're the only one who used the word Photoshop.
I can show you Spirit photography from 1708.
Yeah,
so what are you talking about?
That's going,
what
that's
are
going
you
to be a
talking
double
about?
exposure.
1800s, 1900s, we photoshopped
Can I-
all
All right,
kinds
stop,
of
stop,
stuff.
stop. Let's go to the next one.
Finish my point.
No,
I just
no,
wanted
we
to
should
no,
go
we're going to
to
the
the
next one.
Let's go to the next
Just
one.
make sure we don't get to
Okay.
expose the
Get on here.
Photoshop claim, whatever we do.
Just go to tothemoon.ser.edu.
We got to make sure you guys can keep
Thank you.
repeating your provably false
You
scripts,
can
so we
see
can't let them be
thousands
corrected.
of photographs, the original slide films from all the Apollo,
Oh,
Gemini, and Mercury
next
missions.
question.
Is it just like a cult?
Next
You just
question.
repeat
Hold on,
proof-
Stop, stop,
Let's
stop,
move on to the
stop,
next
stop, stop. We're
Next
moving on.
question.
You can only see Africa.
question.
on
How
that
do I
Gentlemen.
mute people? Can I do that? All
Only
right, thank you.
Africa.
Let's
Next
go.
question.
We got MKE Matt says, Globers, if you know the mass distance velocity of the sun, moon, earth, how is it that supercomputers can't even mathematically model the orbits of just these three bodies, aka the three-body problem? Appreciate the debate. Go.
Oh, yeah, no, I can answer this. So the three-body problem is a question of being able to solve it analytically, right? So if you have a two-body problem, if you just have like the Earth and the Moon, or the Earth and the Sun, or whatever, Jupiter and the Sun, you can actually solve it using relatively basic mathematics. Not basic mathematics, it's still a differential equation, but it's not so hard that like an undergrad can't do it. Once you have a three-body problem, the amount of variables that are involved makes it like, and this is mathematically provable, you can't actually write down a solution to that in terms of elementary functions. We're talking sines, cosines, exponentials, logarithms, polynomials, and so on. That doesn't mean that we can't simulate and model these things. And by the way, this is done all the time. We do use computers. You don't even need supercomputers to solve numerically the three-body problem. You just can't do it analytically. That's fine, but you can do this, and this is done all the time. Like this is what astrophysicists do. This is literally their job. I've seen this code. I've seen it work. It is doable.
Okay, let's go to the next one. Donnie B says, thanks, guys. Thank you very much for the $10. We got another one. Gleam says, to all the panel, please raise your hand if you have tested, analyzed, investigated the workings of the flat Earth model. Those that raise their hand must name whose model they analyzed. No maps. Can you do that again?
Got him.
Wait, what does it mean? No maps? What model?
I love
if no
that
maps.
all the globe people are claiming that
me read
they
it again.
accept this model. We don't accept the model. We understand that there's still more for us to learn. So for us to pretend as if a model is 100% accurate with very limited information that we have based off of the fact that all of our money goes to NASA, which presupposes the globe Earth instead of the level Earth. So what we're trying to do is expose the globe. That way there we can have a real model of our home that includes electrostatics and magnetism and all of the different things
right, let's go
that
to
we actually experience versus this spinning rock in space.
Okay, so the question one more time was, to all the panel, please raise your hand if you have tested, analyzed, investigated the workings of a flat Earth model. Those that raise their
Yes.
hand must name whose model they analyze. No maps. Okay.
Yeah. So to answer that, the one that Whitsitt actually himself brought up, which he claimed is going to explain all celestial phenomena, which the website itself tells you it doesn't. I've looked into the claims, and again, as we've demonstrated here, there is no bendy light alibi that is going to work in favor of the flat Earth. We looked at the model, and there was no answer for these questions.
Okay, Blitz.
These questions.
Blitz, go ahead.
Yeah, so I guess I analyzed what you might call like a series of flat Earth models, basically where you have a local sun beneath the firmament, and the data that I analyzed is Rislauden's. He did an experiment where he measured stick shadow lengths, and we did some trigonometry. We did data analysis. We actually did error analysis as well, and we showed that his data is inconsistent with a local sun that is beneath the firmament.
Okay, globe face.
And consistent with a globe Earth.
Also that.
Yes, also
Lobby
that.
showed a video of how you could change the length of shadows just by changing the angles and all of these different things. So the shadow lengths on two sticks on a ball is not conclusive.
The shadows are
Let me
perpendicular.
explain something.
Oh,
It's
wait,
my
wait,
time.
let's just
It's my
finish.
time.
Let Globy finish. Go.
No, it's not. Your time's up, bro.
My time's up.
Go.
Yeah,
No,
well,
you're
Post
up.
just disagreed with you, Caleb, so
You're up.
you
Caleb.
might want to let him finish.
Go.
Thank you.
No, your time. What?
Okay. The sticks are perpendicular, so they weren't being angled to change shadow lengths. That's you insinuating that the test was done dishonestly, and he's actually a flat earther, Rislauden. So it's not. So it was unbiased, I would say. Anyway, that just threw me off. What were we talking about 2 seconds ago?
Okay, so then we'll go to the
So
other
as we're
side.
talking about the models, I just
What was
want to
the
point
question?
out
Oh
something.
yeah. So the answer to my model question, the
Yes.
answer to the question is that there is no model. So all we can do is study the various maps that various flat earthers propose as solving problems and that, but there never will be a model that works that models everything we see in real life. So
Immediately brought up maps, even though it was in the question not to. But I just want to point out this is something that people don't seem to understand. There is no flat Earth model, and there is no globe Earth model either. We don't have entire models to explain the Earth that quite literally doesn't exist. You create compartmentalized models to explain specific phenomena. So you have the WGS-84 that tries to take the plane survey data, map it up into a globe, and then has all kinds of anomalies, and it doesn't work. You have the geodynamo model to explain the core of the Earth. You have the geomagnetic model, which explains the magnetic field of the Earth. You explain things with different models. If I want to show you east to west circumnavigation, I can give you a frisbee, show you something in the center, and then moving around the center point of a compass with a compass, that would be a flat Earth model. And then you guys say we have no flat Earth model, but NASA and the military disagrees when it specifically says we use a flat Earth model whenever we design our planes and our technology. And you can say it's just because of math. Too bad you can't use your stupid little globe math to make the plane work. You literally can't. You have to use the flat Earth. So in conclusion, yes, we can model out different phenomena, assuming that either the Earth's a globe or that the Earth is a stationary plane, and you go out on the Earth and you test it with empirical evidence, and we can explain celestial phenomena, magnetic field, all better than the globe. So you guys need to stop just repeating the same 2015 talking point because it's stupid and the globe Earth doesn't have a model. Thank you.
Caleb, go ahead.
Citation needed.
Cool. Lies.
Caleb, go.
Cite the globe model.
Caleb, you can't just say that after somebody speaks. It's not going to work. Go ahead, Caleb.
Yeah. So they can't give us a model that explains all of them. Just like, again, I'm just going to kind of be reiterating because Austin said it so well, but they have models for specific things. It's all compartmentalized. There's no one globe model that explains everything, as well as when we take, like there were actual ships back in the day that were off by hundreds of miles when trying to navigate based on a globe. And like there's so much wrong. They admit that there's so much wrong with the geodynamo model, with the flux of the magnetic field in the southern hemisphere plane. Sorry, I messed up saying that. But yeah, neither we shouldn't be looking at models. We should be looking at terrestrial, observable, repeatable, demonstrable experiments. And there's none that can prove that the Earth is moving around the sun. There's none that can prove the Earth is spinning. There's none that can prove that there's curvature or convexity to the Earth's surface. Therefore, we are on a level topographical plane.
Caleb, 20 seconds, go. I'm sorry, not Caleb, Derek.
Oh, damn, I got sidetracked when you said that. So what was the question? My bad,
About the
real quick.
model, have you tested the...
Okay, so that's the thing. If we were to actually study the flat Earth and we put all of our resources into looking into the truth, we'd have a model. That's something flat earthers can agree to, is that we need to learn more. And the globe people refuse to even accept this because they accept all of the nonsense that's handed down to them by their government who seeks to control them. If we were actually looking and studying into the effects like we were back before the 1900s, we would have a far more advanced civilization. We'd have better energy. We'd have better everything, because as the globe people were saying, I mean, Blitz even admitted that the ether might exist and that it's moving with us. Well, if the ether exists, then first of all, that does discredit to the globe, because all observations do not include both. You can't have the ether and a moving object. But also, if the ether is real, there's energy there, and that energy there can be harvested, and we could use it. And the globe people like to make fun of flat earthers for believing that the world could be better. They love to believe that their government and NASA has done the best with the world, and that the world has been getting better ever since NASA came out, when in reality, we've been on a drastic decline ever since we switched our concept to being evolved monkeys and not creation as we are. The entire globe model is based off of a philosophical principle, not science.
Okay, we got chat. Can I just ask a question? I think the chat would like to know from the flat earthers, if to actually answer the question, have you measured or done anything regarding flat earth yourselves?
Like when we measure long distance photographs.
Years. What's measurable?
You've never
and
done
demonstrable?
anything.
Like, what data analysis did you do?
I didn't ask you to ask me what I did.
You asked a question and you just keep talking.
Went out and made physical measurements of the Earth.
Include that in your closing.
Skyline.
Include that in
When
your
we're
closing. Let's get these questions done. We've got $10 from who's this? $10 from MKE Matt. It says, Ballers, can you cite any repeatable observable experiments that show a pressurized system that can exist next to a vacuum without a barrier? Go ahead. I'll give you some time on
Go ahead.
Yeah, so
hydrofluoride. Go ahead. Sorry.
Yeah, so again, I don't know why that's a question that gets asked constantly, because again, I've mentioned this in my opener. It's almost like I knew what the questions you guys were going to ask. I already showed that there is no hard vacuum next to the atmosphere. We have a pressure gradient that slowly decreases, and even in the most vacuumous regions of space, there's still some pressure. Even that 10 to the negative 17 Torr number that gets thrown around is not a negative number. That there is no hard vacuum next to the atmosphere.
Invoke an experiment.
Stop.
To what?
Go. They got
A
a
barometer?
Dr. Blitz.
A container.
No,
Wow.
No, the question is ill-posed, right? Because the question was asking for an experiment that we're not claiming.
Okay.
You can't experiment it? You can't show it?
Well, we weren't claiming the thing that they want us to provide an experiment for.
And we claim the exact opposite of that. There is no hard vacuum next to the atmosphere.
So Earth's atmosphere goes out infinitely into space?
Yeah.
Yes, it's a gradient.
It becomes
infinitely
homogeneous,
into
though.
the edge of space?
Well, no, it becomes homogeneous with the relative density of space.
Wow.
At, 600,000 miles or something like that.
600,000 miles.
Fact check me on that number, but it becomes homogeneous with the density of space at some distance.
Recorded.
Why doesn't it become homogeneous down here? Why doesn't 13.7 meld with 13.6 and create an even atmosphere? What's going on there?
Gravity.
Again,
Gravity.
that's what I explained earlier.
There is a gradient. We know that there's a gradient. So there's never a place where it goes from high pressure to low pressure all of a sudden, right?
So what are the air molecules doing?
That's actually a great.
They're bouncing off each other.
All right, that's a great question.
Let's go to the next one.
Derek. That's a great question.
No experiment.
Because
Let's go to the next one. We're gonna go with Fed Up Gear says for $20. I want to know who's coming to hang with these flat rock stars for live presentations. Good. God bless you, both of your donation recipients. All right, that's not a really question. We've got a Crimson Cable AB88, $20 says to the flat earthers, why do none of you do your own experiments to prove any of your claims and show results? The few that do and find the answer is globe model answers. Why do you continue to deny what you see?
We do all kinds of experiments. Yeah, I've tested electrostatics and changed the vector, the weight, and the actual direction of objects consistently. I've consistently manipulated a variable and shown that everything's intrinsically electrostatic, and you can make things flow with that variable. We've gone out and done mirror flashes, laser tests, long distance observations, time lapse from different directions. We've done all kinds of. I've taken time lapse over the marine horizon; they never intersect with the marine horizon like they should on the globe. I've done all kinds of tests. Ironically, the globe earthers have never gone out into the real world and tried to see what's really going on the earth. They only talk about it from behind a screen. So
as well as hell, it's our time. Calm down. Impulse control, buddy. And when they do, they invoke things like geodetic surveying, which is plane surveying taken over 100 square miles, where they assume the Earth is a level plane. They stitch all of that data together, do a bunch of math and a bunch of baked-in assumptions to assume that the Earth's a globe. So whenever we go out into reality, whenever we build anything reality, whenever we try to simulate planes flying, we have to assume that the Earth is level and stationary and flat.
Why doesn't geodetic surveying work on more than 100 square miles?
Because
What?
if you look after you look over 1,500 feet of the atmosphere, there's an effect. So they admit that they can only do plane surveying over 1,500 feet. If you know anything about surveying, you'll know your answer to your question.
Okay, for $10,
We have
got-
an atmosphere.
Can the flat Earth guys explain how when you watch a sailboat, when you watch a boat sail out to the ocean, it doesn't just disappear; it seems to sink. This is the easiest way to debunk. It will happen anytime, anywhere with open ocean. That's Josh Hancock. Thank you very much. Go ahead, Flat.
Well, if you were to even take that question, put it into Chat GPT and ask, does the sinking ship effect work on flat Earth versus globe Earth? And the answer is yes. This is because the atmosphere acts as a lens. It compresses the things. The light is bending. The further away this object gets, the more distance that light has to travel while it's being bent downward. So light that's reaching your eye from lower part of the boat is going to seem lower because as it travels the distance, it's physically lower as it's being optically lower, not physically, but it's just being bent downwards. And this is because you're looking through the atmosphere, it's compressing it, and it's lowering the apparent location of the object that is far. The further away that object is, the lower it appears. And this is why some days when we don't have refraction, we could see really far, is because the light is actually reaching your eye. It's not being bent downward by the medium.
So also the Globers say that the boat's going over the horizon proves that the Earth has curvature. You'll see Bill Nye and other psychos say this kind of stuff. But when it goes out of the visual perspective due to angular resolution, you can take a P1000 and zoom these boats back in all the way to the hole. So all the way to the bottom of the boat. So that's a problem. Shouldn't be able to do that ever.
Okay, thank you. We'll go to the next one. Just something that I want to point out. I think that we've got a pretty obvious contention point too with the whether or not we're getting light that bends up or down. So if somebody can develop a pretty good experiment or way that we can get that ironed out, because we got side saying things are being shown higher.
This is
than
well
we are.
understood optics. This is taught to freshmen. I
Actually,
don't know
in
what the
reality,
convention
it's based on the actual vertice of the interaction and the intersection and what angle you view it from. And so we can bet on it. Let's do a live stream where we bet on it, and we can see if we can make things refract down and displace physically or optically down towards the denser medium. Do you want to do that?
Yeah, let's do that.
Because it's so simple and it's
what
not
are you
night
asking?
traders.
That's Snell's law. Light does bend towards the more dense medium. This is well understood.
Not up. You're saying
I could go grab a pencil and a glass of water. And
we all agree on it bending down, but it's whether or not.
By the way, I'm sorry.
Causes
I
it
just
to
wanted
tear
to
up.
say one thing though. My camera froze, and I know you didn't want me to turn off the camera. Should I just leave it, or what should I do?
No, try. You
Stop
can
it and restart it.
Yes, stop it and come back in. It should be fine. I'll reorganize if I need to.
So yeah, you're right, Jaron. We should test it because it seems to actually be relative to a variance of factors. And
Wait, so do we
visual space is
agree that
hyperbolic.
Snell's law is a thing?
Snell's law is one of the more accurate we have. Yeah.
Okay, just making sure.
You know it's
Because
not
that's
perfect,
the-
right?
of
You know it doesn't
course
actually
not.
really work that good sometimes.
You're back
It
again.
works. It works fairly good. It works fine at a classroom level.
All right, the next one
You should look
from
into hyperbolic geometry, dude.
Zetetic.
Dude, that's literally my area of study. But anyway.
Really, visual space being hyperbolic? You've
No,
researched that?
I study non-Euclidean geometry.
You should apply it
I'm
to
a
visual
differential
space,
geometry.
my brother.
It'd
I'm
be
just
great to hear
saying,
you guys
check it
together,
out.
but let's not do that today. Can the Globies explain the analemma practically? $10 from Zetetic.
Sorry,
West.
one more time?
Can you explain the analemma practically? Go.
Oh, like the figure 8 that the sun makes in the sky.
Yes.
Yeah, so again, that's just because obviously as the Earth is tilted and we go around the sun, that tilt stays the same. So as we go around, the sun's going to appear in different locations in the sky. Similar actually to what flat earthers say, it will appear between the tropics.
Okay, Blitz or McGlowface?
No, I'm satisfied with that answer.
Yeah.
Okay.
It's all about the tilt.
Ballers, can you cite any repeatable observable experiments that... I'm sorry. We already read that one. This one's from Jesus Christ is Lord. $10 says, what about NASA losing all the moon data? I guess that's for you guys, Globies.
They didn't
lose that.
They lost what? They lost Apollo 11 telemetry.
Yeah, just the Apollo 11 telemetry.
Yeah, just the most important one.
Well, no, but there were 5 other moon landings.
Well, now that they walked on the Earth and forecasted it to the entire world, huh? Broadcasted it.
Telemetry prove they went somewhere, or is it?
We'd at least be able to fact check some of their evidence. No, it wouldn't prove anything.
Well, we have the telemetry data for the other missions. So
Yeah, and it all
those fake?
contradicts the official mechanics of the claim.
Globey, could
We've
you
never
actually
looked at it.
expand on what telemetry is, just so everyone knows?
I'd like for them to expand on telemetry. I'd like to hear what they think it is.
Oh, that's a good point.
Who's talking?
Yeah, there's a variance of things
Sorry,
that
that
would
was me.
fall
Oh,
in
you're
the
on
category
stream.
of telemetry data.
My bad.
Speeds,
what's that?
distances, orbital trajectories, the actual path and times and locations relative to different stars, different celestial positions. There's all kinds of telemetry data that should have been documented. When we actually look at the other missions, they don't match the orbital trajectories and mechanics claimed to land a lunar module on a rotating moon with a lunar surface that has a slight atmosphere, but it really has no atmosphere, and then accounting for the moving object and the orbital trajectory. When you actually look at the math, it doesn't work, and they even exclude that math from the other Apollo missions. So you guys can make all kinds of claims, but if you think we landed on the moon in 2023, like I think you need to chill, bro. You need to re-examine your.
Can you link me something? Where like
Yeah.
they check the math, please.
Okay,
Like,
can
post
we-
it into the chat or something like
Let's
that.
keep going. We gotta-
Yeah.
Must
We
be
want
much
to see where they
appreciated.
analyze the telemetry from the other missions, and it didn't line up with the landing. That would
With the
love-
orbital mechanics.
Yeah, no, I'd like to cite
Yeah.
your sources. I'd just like to see a link or something.
Because they had telemetry from Apollo 8 went there. They had that telemetry. Apollo 9, they had that
I like how
telemetry.
they flawlessly landed on the moon.
Fif-
The
15
first
to
time when they
17,
crashed
they
the
have that
rockets here.
telemetry.
Dude,
Anyway,
they
next
claimed that
question,
when
yeah?
they landed on the moon, that the computers went down. He had to just eyeball it, accounting for the angular rotation of 10 miles per hour and the 2,200 mile per hour orbit around the Earth whenever they went and landed and descended within maintaining an orbit. They just lost all that. For all the missions, they don't even show you the specific math of that, ever.
No, they,
Ever.
What do you mean they don't show you the math of that?
They don't show you the math for
corrected-
accounting for
there
the
was an
orbital
error.
trajectory and the rotational velocity of the moon. They don't show you the Earth, the actual descent ratio and adjustment.
So all the math to get there was done physically on paper, right? So they know there was an error with the math in the guidance system for Apollo 11, and they corrected that error for the future missions.
Oh,
So
is
I
that
don't
it
know what
went
you're
down?
talking
It wasn't that there was an error with the actual
Nothing went
like.
down. There was an error in the code. Yeah.
Oh, so where is all the other
Guys, we'll talk about that
math
some other
shows
time.
how it works?
Let's go to the next question. Mason Benoit says for $10, pointing out ridiculous coincidences they cling to, like 108 suns fit between the Earth and the sun, 108 moons fit between the Earth and the moon. Perfect order forms through random chaotic explosions. Denial. Okay, I don't think that's a question. We've got Ethan for $10 says, thank you very much, by the way. Globers, if NASA admits they've been lying and admits Earth is flat, would you believe them? And give us one example each of something we can do to prove the Earth is flat. 3 sufficient proofs, 1 each. Okay, so I guess that's for both sides. Globers go first. If NASA admits they've been lying and admit to Earth is flat, would you believe them?
Well, I guess it again kind of falls on the same premises that it would with these three gentlemen here. If there was sufficient evidence to prove that, then sure. I don't just believe claims just because it was claimed. I have to see the evidence.
Okay.
Yeah, I would. If they would have to come up with some really spectacular alternative models to explain why we observe what we observe. If they could do that, sure. Yeah, that'd be fine.
Globeface?
Same thing. And if they could figure out the Southern Stars things without invoking magical, bendy, 180-degree light, I would believe it.
Okay.
Or maybe they can invoke it, but they have a better theory of electromagnetism than Maxwell.
Sure.
Okay.
Maxwell's theory is provably accurate, incomplete, and don't work. Of course, we've already corrected you guys 3 times that it's not 180 degrees. You just keep baselessly saying it anyway. We've also explained that it's not physically bending. It's just optical effects. And no true earther would ever just blindly believe what a governmental agency says about the nature of the Earth. The reason that we're true earthers is we go and test it ourselves empirically, and we narrow it down to what can be empirically verified. We don't blindly regurgitate the idea of
one
consensus
thing
and
each.
authority.
Wasn't that a
Flat-
Glober's question?
No,
I
that's
thought it
for
was to
both.
each question.
Flat side, you get one. They want to know one. Name something that we can do to prove the Earth is flat. 3 sufficient proofs, 1 each. So, Caleb, go
Oh,
first.
sorry, I misunderstood.
So
You guys
you
go ahead.
Can do a simple mirror flash test over 40 miles. There's 66.6 feet, I believe, over 10 miles of physical curvature that would be necessitated over a ball that's 24,901 miles in circumference. We're seeing the mirror flash at a 0-foot observer height. FE Core themselves did a bunch of laser tests proving that the Earth
Well,
is
I'd
flat.
ask for one. So,
water
mirror test is for
stationary.
you. Witz, go.
Oh, that's tough to pick one, but we'll say, how can wells send arguably up to 10,000-mile horizontal sonar propagation through the ocean? I guess you can't invoke the ionosphere there. So if anyone wants to tell me how you're sending horizontal line of sight propagation 10,000 miles from well to well, that'd be great.
Okay, Derek.
Well, measurements. Measure the Earth. If you're going to try to prove the shape of the Earth, look at the Earth. When you take long distance photography, you measure with lasers on distances. You could measure the distance between the top of a building and the bottom of a building at a distance. And if the Earth were a ball, the top would be slightly further apart than the bottom of the ball. But when we take these long distance measurements, they're equal, which means that they are on a level plane.
All right, we got 15 minutes left. So remember, if you super chat $10 or more, you'll get your question read, and they are all going to 2 different charities, or less fortunate that both sides have picked. So we've got about 5 more questions. It looks like Globers, according to your model, this is from Release the Band. Globers, according to your model, why did the shadow of the moon travel from west to east during the solar eclipse of 2017? Give you a minute.
I don't know about that eclipse. I don't know what he's talking about. Do you guys?
Anybody on the Globe side?
No idea what he's talking about.
Yeah, I've never even heard that until now.
Okay, so I'll just tell you again, just so you can, maybe if you want to look into it. He's saying that there was the moon that traveled from west to east during the solar eclipse of 2017, and in your model, I think they think it should go the other way.
Okay, I don't know.
Okay, for $10, for each Glober, how would your life change if the Earth was indeed flat and the globe model was a complete lie? That's from Pardon My Folly.
Yeah, my life wouldn't. I work in a math department, and they don't care what shape the Earth is.
Okay, how about Globe Man?
I mean, I don't know. I'm not a scientist or anything like that, so it's not really going to affect me that much. I guess it would make me look at the world differently, but I would still be here playing video games, doing fun stuff.
Okay, and Globeface?
Personally, it wouldn't. I guess I would have to change my name to Flatty McFlatface and destroy Glober conspiracy theorists on TikTok.
Nice.
Wow, that would be an improvement.
Gotta keep the content going.
We've got $10. Thank you very much from the dude, but no question. Then we got $20 here for Run Boston Bear, who says, "I'm so grateful to have woken up to the globe deception. Understanding what we live on is fixed and up in the same direction for everyone brings peace. The Creator is directly above us and not that far away. Praise be Yeshua." Okay, that was not a question. $20 to all. Do any of you believe in Genesis 1:6, whether it be a dome or firmament Bible translation? If so, does that weigh any of your beliefs, flat or globe? That's from Qual Yasha. To everybody, I guess. We'll go with Globan. Do you believe in Genesis?
I'm not religious. I don't even, I haven't read the Bible, so
okay.
I would say no. If it's mentioning a dome, no. But as far as I have heard, again, like I said, I haven't really looked much into it because I don't argue religion.
Okay.
But if I remember right, the original translation would have been Rakia, which translates to expanse.
Okay. Blitz?
Yeah, no, I don't take it seriously. It's a book from 2,500 years ago written by Iron Age nomads.
Okay. My Globe Face?
Yeah, I don't trust people enough to believe a book written by them.
Okay. Caleb?
So I think it's funny that all cosmology, if you were to look up Egyptian cosmology, biblical cosmology, Australian cosmology, they'll all show a flat earth with a firmament over our head. So I wouldn't invoke that in a debate setting, saying that Genesis 1:6 proves that there's a dome over our head. But I think it's interesting that every single cosmology in our ancient history said that the earth was flat with a firmament over our head. So
what's it?
Yeah. Obviously, I put weight into the scriptures. Personally, that doesn't prove anything, though, one way or the other. It actually is firmament, rakia, beaten out, strong as bronze. It's funny that people that claim they know nothing about the Bible then go on to tell you what something means in Hebrew when they don't. But anyway, yeah, like it doesn't prove anything. I mean, physically speaking, there would be a toroid over top of us. We would be actually experiencing the top half of it. So yeah, that's effectively a dome structure. But obviously, scriptures don't stand weight in empirical debate.
Derek?
Yeah, and like these guys, I wouldn't use it in a debate fashion, but what I would say is everything is 99% energy, and for us to try to take our understanding on the physical off of the 1%, less than 1% of the reality that is physical, wouldn't be very smart in my mind. So for us to try to pretend as if we know what it is, I don't think that's scientific, but I do believe that there is something there. We could call it the firmament. It could be the end of the frequency, could be a firmament. I don't know, but yeah, I don't think that invoking scripture is a good argument, but I think that it's a good place to look.
Okay, we've got up next Joshua Kelly for $10 says, "Is it just a matter of who's telling you? Does it have to be NASA saying the Earth is flat for you to actually take it seriously?" That's for the Globe.
No, actually, if just NASA said it and didn't give any explanation, I wouldn't believe them. I would trust my colleagues with the models that they produce and the experiments that they do.
Okay.
I'm not talking about these guys, by the way. I'm talking about my colleagues in academic circles.
You just said your colleagues have nothing to do with the shape of the Earth.
I wasn't talking about them, like these people. I was talking about the experiments and models that they produce to explain how it could be flat.
Got you. Globe Man, any question, any answer for that?
I don't know. I guess I would kind of sit on the same place that Blitz does. Like I said before, outrageous claims are going to require outrageous amounts of evidence.
Okay. And Globeface?
Yeah, same thing. As kind of the same answer as the last time.
Okay. We got another one from David Kahn, I believe. Yeah. David Kahn says, just woke up. I am on sleeping. I can't read that. That's not a question. We've got $10. Thank you very much from Geocentric Truth says, is there more lands beyond the pole? What's it?
Yeah, so I mean, the South Pole would be beneath you if you understand that we're on the inertial plane. But yeah, there does seem to be a decent amount of strong evidence that there could be extra land. Yes, a lot of people that claim that they went there, people claim that they were born there, people claim that they experienced, explored it, that there's a summer's gate. I mean, obviously, I'm not going now. People can laugh and ridicule and mock, but you guys are blind believing that. Well, the government said don't go out here. We looked for you. I promise there's nothing out here, and that's literally all you have to go on. So yeah, I think there could definitely be more land. Yeah.
Okay. Globers. This is from Ethan0406 says, Globers, 3 things that we can do to prove flat Earth. 1 each would be sufficient for you guys.
Sorry, one more time?
Yeah, I'm confused. Globers, 3 things we can do to prove flat Earth. Okay, so he's asking for 1 each.
But what kind of evidence that we would accept?
1 each of you. Go ahead. Globeman.
So, as Derek mentioned, he's claiming that reciprocal zenith angles, again, that's going to be 2 plumb buildings seemingly, tilting away from each other due to the curvature of the Earth. If you can provide actual experimental data, I would love to see it, because I actually happen to know that reciprocal zenith angles do not measure 180 degrees. They measure greater than that. An example of this would be the Verrazano-Narrows Bridge. Post-load, they were actually built to tilt away, but preload, they were built to tilt away, but once the load was added, that pulls them into plumb. This is standard practice for building bridges, and we can see that if you measure that, the tops, in fact, are further apart than the bases would be.
Well, you just said that they built it that way, that they built it to be stacked on to come together. So you're saying that
preload.
Okay, Blitz, go ahead.
Yeah,
Preload. I'm sorry, are we allowed to counter comments?
Well, you each get one. So Blitz, go ahead.
So Riz's experiment would have been really good. Like I did the analysis for him. He gave me the data, and he's like, look, like he was a flat earther. He's like, look, let's see what this says. And I just did the numbers. Like all I did was numbers. And if it came out that the globe Earth made incorrect predictions, I would be like, well, damn. I don't know. Sorry, am I allowed to swear?
Yes.
Yeah. Okay, man.
So that's like I would have just been like, well, I guess that's it.
It's just that
potty mouth.
Yeah, I was gonna say. Wits it will think you're weak, but besides that, you can.
They're called weak words, not swear words. Yeah.
Globeface, go ahead.
I'll make it easy. 1 picture of the firmament.
All right.
What about a government document about the firmament?
Nope, government doesn't count unless they like what it says.
Mason Benoit says, Globers, thoughts on Apollo 8, 1968 live Christmas Eve broadcast? Nothing was more appropriate than quoting Genesis 1 from the KJV, the firmament dome, gravity is satanic, founded in 1666. Go ahead.
Was that a question?
Well, thoughts on Apollo 8, them reading the Genesis portion of the Bible?
Yeah, people are religious. They like to quote their scripture. It's fine.
Okay. Any other comments there, Globeman, Globeface?
Nothing really.
Okay.
Kind of like what it said. We can't really use scripture as proof one way or another of anything.
Okay, Exoteric says a Globy video once said that the moon lander was covered in space foil. What is it? Who makes it? And how can we test that?
Mylar. It's insulation. That's it. I mean, what is there to test? It's just insulation.
Well, just throw the lunar lander in a vacuum and see if it works.
Test its rigidity.
Yeah. It wasn't enclosed by Mylar. It was enclosed by solid aluminum.
Can we throw the lunar lander that's in the museum in a vacuum? You think?
Pressurize it first.
Yeah, the cabin where the people were pressurized with solid aluminum. Yeah, the Mylar was covering the bottom. It was used as insulation. It wasn't keeping pressure inside of anything.
Are you aware of the interview of the astronaut who said if you were to lean on the wall of the lunar lander that you would actually poke a hole through it if you took your finger and pressed hard enough on it? What about the air pressure
Parts of
inside
it.
there that allowed for them to take their helmets off while they were inside of this thing?
Parts of it you could push through. The parts that didn't
Like the Mylar.
Okay.
Yeah, the Mylar parts you could poke through. The parts where the astronauts were, you could not poke through.
So I'm saying if we just took the lander and we put it in a vacuum today, do you guys think it would just stand up to the vacuum?
Well,
Like the one in the
it's been sitting
museum?
around for 50 years. I mean, seals might be rotted, but yeah, I think it would. It would have back then for sure.
All right, bro.
Okay, does the any flat earther have any accurate flat
So
earth map?
that's an incredulity thing. I mean, you just laugh.
No,
at it,
I'm
but
saying
can't
I've
be
never
true.
seen the test. I just think it looks like a tweaker got a Home Depot card and pulled out some
I
duct
mean,
tape.
it's the definition of incredulity. You have
I'm
to
not
know
claiming
that,
it's
right?
not true because I think it's retarded and
That's what you
stupid and
just
unbelievable.
said.
No, I'm saying like, can we test it? That's what I said.
You just said it looks ridiculous. So how could it be?
No,
I said, can we test it? I said, I'm just saying, could we not just take it and put it in a vacuum and see if it
Everyone
works
heard what
today?
you said. Okay, next question.
Does any flat earther there have
That's
an
right.
accurate flat earth map from second best Bob?
No, we don't have hundreds of millions of dollars going to cartography to create us a map. It's all going to a globe Earth that doesn't exist. You guys can say whatever you think. What's it in?
Okay, what's
Well, the map's relatively accurate until you get far enough out south where coincidentally we see that, in case you guys don't understand, this really fast. So like we got the latitudes from looking at different angles to Polaris on a flat Earth. Then they put that on a globe, and then they put that on a cylinder. Then they flattened that out and made the Mercator. That's objectively how you guys got your current Mercator map. And then whenever like Gleason went to do different maps and map everything out, they basically say you have to use this longitude latitude system to publish official maps. So they've literally made it where you have to publish under the parameters of the longitude latitude system, reifying the globe. And then when we go further out south in these latitudes, we find out that when we sell in the real world, assuming symmetry of a globe with celestial navigation in the south, we're off by dozens of miles a day, hundreds of miles in a week or two. So yeah, I think it's very interesting that the south is drastically different than what we may know about. And no, of course, we don't actually know a perfect map because of those reasons.
Okay, Derek.
Well, and to add to that, all of the maps that we have are off. So Greenland's bigger and some projections, smaller in others. Africa's bigger or smaller. I would just point out that if you're going to complain about, say, the size of Australia on the Gleason map, you're going to have to address the fact that all of your maps are wrong, like, admittedly. And that if we were to actually have the funding to look into this, which people have, and there are new models being developed, but until then, we have to look at what we have. And so what we have is a whole bunch of third world countries being shrunk, first world countries being blown up to better suit the needs of those people who are making the maps.
Okay, we've got flat earthers. Where is proof of your ice wall that surrounds us? If you believe in if not, you believe in fairy tales. From Scat and Foo 15.
There's so many pictures of it.
Well, we know there's ice walls. Like all the southern people, all the people that went to the south and explored, they reported this, and it's illegal to privately and independently go and verify this right now. So the truth is, the Globers should be on our side, trying to demand that we're allowed to freely do that. You can't even get close enough past the 60 south latitude in the water to see it. So you guys should look at the actual evidence of the mariners and navigators that went there and said that, and then question why we're not allowed to go right now.
There's yacht races that go around it every year.
They don't actually go around Antarctica, so it shows you guys. No, you guys don't ever look into things.
Oh, they go around the outside of the pizza world? Is that what they do?
No, like if you're talking about the circumnavigation specifically, the circumnavigation races don't go around Antarctica. They tip over, they go over a little bit of Antarctica and pop back up north.
I'm not talking about circumnavigation races. I don't know what you're talking about.
Also, the general guidelines for visitors to the Antarctic posted by the IAATO, they explicitly tell you that you are allowed to go on your own, and tell you the only places you can't go are ACBRs, Antarctic Continental Biogeographic Regions, and those are lined out.
Okay. So they say you have to give 3 to 6 months in advance notice. No external water supply, no external fuel supply. You can't go past 60 south latitude without approval. You must actually give them your route. They must approve your route 3 months in advance. And then if for any reason they want to intercept you, you completely have no Fourth Amendment rights once you're there. And that's specifically for the United States.
And if you're in trouble, they will help you.
Why misrepresent that? We can't go to Antarctica. If the Earth's a globe, we should still admit it.
To be clear, that's only true for signatories to the Antarctic Treaty, right?
Yeah. So wait, do you think that some smaller country can go past?
I mean, citizens of that country can, yeah.
Really? So you think that they're
They're
not going
not
to be
bound by the
intercepted?
treaty.
Not going to be intercepted by the major world countries. That's what you think?
Are there soldiers on Antarctica?
Well, people have been intercepted when they traveled out without clearance. How do you
No.
think they enforce it? How do you think the
Hold
U.S.
on,
military
Wait,
enforces it?
hold on. What's it? You
citing-
referenced the
Sorry.
Antarctic Treaty, so you're the one
Yeah.
referencing the document that's the treaty between those countries. So that
Yes.
treaty says anyone not in that country can do those things. You're the
Okay,
one.
but that's not reality, though. You can't actually
Do you have
go.
evidence of this?
Evidence
What,
of it's
what,
not-
what's
Yeah,
that? Like somebody from a country who's been
Norwegian
stopped?
seller, a Norwegian seller tried to go and was intercepted 3 different times.
Yeah, and what's I just wanted to say, I recommend you read the Antarctic Treaty if you're going to claim there's military there that is intercepting people, because the first
Says
article
no military
of the
presence.
yes, the first article of the Antarctic Treaty, which you just mentioned, goes against your own claim.
Isn't there military all over the place there?
Dude, I've already
tons of
like
military
okay.
there.
First of all, there are military quote unquote base, but they call them scientific. Secondly, there are tons of subsequent languages or like actual legislation since then. You guys should read the actual subsequent legislation as well, and it specifically says in the articles of the Antarctic Treaty you can't go privately without permission. So
Okay,
why
can you-
misrepresented that?
can
If the
we
Earth's a
agree-
globe,
Hold on,
you
let's
guys
move
are
on. We're
making
good.
more
We're
flat
already at
earthers.
3 o'clock.
Can we
We have a
just
couple
agree
more.
real quick that everything you said is steps that you'd have to take to go?
Yes.
Assuming
And it requires
everything you said is-
permission.
Okay, assuming everything you said is right, those are the steps you need to go. So no one's saying you can't anyway. So why wouldn't they just say, hey, no one goes. That's it. You can't go.
That would be.
Why are there
yeah.
steps allowing you to go? Your own argument doesn't make sense.
It's limited
Okay,
to get
we'll
people
let-
thinking like you. Sorry,
We'll
what's
let
it?
the audience decide next.
Oh,
question.
Okay,
I
Gleason's.
just-
I think Jaron was
Also, I
trying to
just
move
want
on to the next
I want
Yeah,
to
let's move
point
on.
out real quick before we transfer. They were saying that the treaty is for those who signed the treaty. If you read any law in the United States, it's based off of the residents of those states, Oregon, Washington, whatever. But if you come from out of country and you do one of these things that are against the law, guess what's going to happen? They're not going to be
Nobody
like, oh,
owns
you're
Antarctica.
from Colombia. I guess you
Nobody
could
owns
go
Antarctica.
doing this. No, that's not what they're going to do.
Nobody
They're
has
going to
sovereignty
arrest
over
you and they're going to
Antarctica.
treat you as if they would anybody else who broke that rule. So
Nobody
whether or
has
not
So,
sovereignty
Dr.
over
Blitz, I have a
Antarctica.
question. So, if you go there, you can just
I
commit
guess you're-
crimes.
You're not understanding what I'm saying. So continue.
I just
Just
want.
next question.
Yeah, Dr. Blitz, I want to ask. Can we go there and commit crimes? You're saying?
Yeah, thank you.
So I actually think that you might. I'm not a lawyer, and I would ask my wife, but she probably doesn't want to talk about it.
Okay. We've got why? Oh no, sorry, that's not. Tim Bucks, explain why the Earth is flat within its toroidal field from Mikan.
Yeah, so every single magnetic field has something called a block domain wall, or a more accurate description would be an inertial plane because it's an unchanging plane, so it would be inertial, but it's called the block domain wall. That's, of course, named after the discoverer Block. And inside of a toroid, you have pressure mediated from both sides. You have the north and the south section, so you have centrifugal divergence, centripetal convergence, because we're running out of time. But anyway, you have a plane in the middle of all magnetic fields called the block domain wall. Well-known phenomena. The Earth would be within that inertial plane. In fact, the dielectric plane inside the inertial plane would be the only place that could sustain life.
Okay, thank you to Lynn Belland for $10. She says, "Love my flat Earth family. You guys are killing it." We got $10 for Blitz from Mason Benoit, who says, "Blitz, explain how a rocket produces thrust in space with no air pressure to push against."
Yeah, can I draw a picture?
You may.
Yeah, 1 sec. Let me turn off my. Well, let me adjust my camera so that it doesn't capture my wife because she doesn't want to be on the camera.
Okay.
And I'll draw a picture. Sorry, I'm tilted now. Right. Let me draw a picture really quick.
Okay. Are we supposed to
turn
see
off
it?
my background?
Okay.
No, not that.
I was gonna say that was a bit of an awkward silence there.
Yeah, sorry. Okay, here's the picture. Right. Okay, the way a rocket works, this is how all rockets work. This is how recoil works. You have a cup-shaped thing. You might call that the thrust nozzle. You might call that the exhaust nozzle, whatever you want to call it. And then you set off an explosion in the middle, right? The explosion shoots stuff in every direction. Now, some of that stuff goes out that way and doesn't bump into anything. Some of that stuff goes that way and bumps into the rocket and pushes it forward. That's how.
So, Blitz, in the Earth's atmosphere, this makes sense, right? But say you are, I don't know, in outer space in a vacuum, is there going to be a negative pressure or a pressure variance that's going to change the amount of pressure?
I didn't talk about pressure at all.
I know, and that's why I'm bringing it up because you failed to mention it.
No, I don't need to. I don't need.
So
it
if
to
you
explain
took
the
a
phenomenon.
balloon, right? So you're basically saying if I blew up a balloon, I let it go, it's going to blow around my room. What if I take that balloon, I attach it to a vacuum, and then I let it go? Is the balloon still going to go flying freely to my room?
I don't know how.
It's not going to. Guess what it's going to do? It's going to sit right there and not move.
That's not what a rocket is, though. A rocket is explosions. Like it's not just a pressure difference that's causing this ejection of matter.
Mass ejecting mass, correct?
Well, it's explosions,
Well,
and the
and-
explosions cause mass to be ejected.
So if you have a negative pressure on the outside of the rocket, the pressure would what, Blitz? Would it just not be any?
You have
different
higher
in Earth's
pressure in the
atmosphere?
center of the explosion than you have anywhere. So yes, the explosion will go outwards. The explosion will happen. We know that
So
explosions happen in space.
So if like you're saying that it's like a balloon, right?
So
Like you
did
looked up a balloon.
no, I didn't say it. Did you understand the picture? Right.
I'll
So
clarify.
like explosion.
I'll clarify for him.
Pushes
Blitz.
things.
He's saying that the negative pressure outside will suck the explosion out before it can push off of it.
As it pushes.
That's what.
Yeah,
he's
they claim there's an
saying.
oxidizer on board that it creates the interaction inside the actual rocket, and then it just has a little bit of momentum. But since there's nothing blocking it or impeding it, that it can create that forward momentum, and it will be enough for it to work. But when we test this inside of a vacuum chamber, it only works if the actual interaction hits the chamber itself.
Well, to be clear,
That's just a
this can
false
happen with
statement.
solid. This can happen with
It's a fact.
solids, right? Like there's no gases involved here. If you have a solid cup and a solid explosive, and you detonate the explosive, it will push the cup. Atmosphere or no?
Yeah.
A cup.
The
Oh,
answer
it's
is
just
Newton's
Newton's
third
third
law.
law.
It's
Oh,
Newton's
there we
third
go.
law,
Yeah,
and it
it's-
doesn't
it's-
invoke pressure anywhere in Newton's third law. This is how jet engines work. They do not push air. They move the mass of the air that it's intaking, combust it, and accelerate it out the back. It's never pushing off the air behind it.
Like
That's
from
not
The
how
jets
things
work by
move.
the fire doesn't push the jet. It's the actual reciprocation of the air interacting with the fire. So the equal and opposite reaction in Newton's law requires
So
the
can
equal and
anyone
opposite reaction.
confront this picture? Can
That's
anybody
not
explain how this doesn't work in a
patently
vacuum?
false.
How does this not work in a vacuum?
Wait, why are you using a cup? What I'm saying is put a rocket in a huge. You could test this by using a little bitty rocket. put it
Because
in
a cup is a
huge
simplified thrust
vacuum
chamber.
You could test it by putting a little rocket in a huge vacuum chamber where the actual interaction won't reach the boundaries of the chamber, and
Mhm.
see if you can move that rocket forward. And it's
Austin.
never been done.
Yeah. So you can't confront this,
No
right?
video.
That's
The
the
high's
point.
gonna
Like you
seek
can't
the
confront this.
low.
Show
and
us
the
a video
low-
of it working.
Austin,
did
if a
confront it.
person,
Okay.
if a
Yeah.
person was standing in that vacuum chamber on a skateboard and threw a bowling ball, would he also roll backwards?
Okay, I love that you asked that. What if he threw a bag of feathers?
Don't
Because
ask
Yes, he
in
would
me
still
space-
he would still roll back.
You could
yes.
throw a bag
For
of
what it's
feathers
worth,
and move.
Jeranism. This question was for me, and it's gone on for quite a while.
Okay, we're good.
And I think I've addressed the question.
You have.
Yep. Next question. I
The
agree.
answer is yes. He would
Where
roll
do
backwards.
where do
Yeah,
rockets
show
go
me,
for
Jeremy.
flat side? This is from David Rosanini. Oh no, I'm sorry. It's from Caleb Simpkins, who says, "Globers, sorry, where do rockets go for the flat side?" That's the question, and it's from David. My bad. Where
that?
do rockets go flat side? So we see rockets take off. Where do they go?
Oh, they do parabolic maneuvers out into the ocean.
I showed that in my intro.
Okay. We've got can the Globers explain how from an altitude of 6.62 miles up allows you to see the horizon line at 2K plus miles instead of 229 according to the 24K miles Earth circumference from deep dive?
Sorry,
I
what
would have to
deep
see
dive?
that
I'll try it one more time. I don't know. He's
Andre.
making
What's the claim?
making a claim that can the Globers explain how from an altitude of 6.62 miles up, which is what 34,000 feet, allows you to see the horizon line at 2K plus miles instead of 200.
I don't know. I don't even know if that's true.
Yeah, I would have to. You're gonna have to provide a link or something. What? What?
I think he's
Yeah,
saying
I don't think the claim is true, so I don't know why we.
Yeah,
have
I
to
wouldn't.
explain
You
it.
wouldn't have to answer that. All right. So from the insane Pollock, for $10, he says thoughts on the person that accurately mapped our level realm reflected in the surface of the moon. Anybody have any comments on that?
Yeah, the only map that shows that is a random map that no one can trace back to anything that someone claimed was on the wall of the UN.
Okay.
It's got the continents on one place that we know of, and then other continents around the outside, and those match up to the dark places on the moon.
Talking about a guy who recently took different projections of the continents and then mapped them perfectly on areas on the moon. They match perfectly with different projected continents. So a little bit different, but yeah, you're right. Someone spread some misinformation on Twitter about the United Nations wall, probably to discredit flat Earth. So.
From what I've seen, whenever I see these moon, normally they're like moon plasma projections or whatever they're called, they're just kind of randomly placing like continents. Like for example, one that I saw, Africa, was literally like, you know how it has it's kind of shaped like an upside down boot almost. It was like going outwards, like diverging away from that point. I don't even know how to like describe it without a visual.
Yeah, some of
but
them
it
are
just doesn't-
huge reaches and don't actually match what it looks like. I agree with you. You should guys look at Taboo Conspiracy's most recent, though. It's actually very accurate.
All right,
Just so I make sure, deep dive. Andre put a comment. He said it's true. Jay Tolan has taken a photo and video about 2,000 miles of the horizon line from 35,000 feet.
It wasn't 2,000
So
miles.
yeah, check into Jay Toll and stuff, but I don't know. I've never heard him claim 2,000. I heard 1,000.
I've
I
heard
think that's
700
2,000 kilometers is 1,000
Oh,
miles.
2,000
maybe
kilometers.
kilometers.
Yeah,
Okay, gotcha. So let's just do this. You each have 1 minute to close it out. Make it. It's not a question. It's not time for you to try and attack somebody else. It's just your final
Thank you.
statement, and then we will head out. So let's start with Caleb. You want to go first?
Sure.
Go ahead.
As we've seen here today, there's no experiments that can be invoked to prove the motion of the Earth and its axial rotation. There's no experiments that can be to prove that the Earth orbits around the sun. All they have to do is claim refraction, actually bends things down, but it's actually bending things up. We can see that all of this is just semantics. The Earth is actually a level topographical plane when we do any terrestrial experiments on the Earth. There we go.
That's all you want?
Sure. Yeah.
Okay, we got Globe Man. Go ahead and go first. You go. You can start whenever you want.
Yeah, first of all, I wanted to say to you, actually, I was skeptical at first to come on here, just because I had only heard of your name. I had never watched your content. So I want to thank you for hosting. You've been a really good, moderator, so I appreciate it. But yeah, I feel like I've kind of driven the point home multiple times. I keep saying it. The Southern Stars are really a flat Earth killer. There's not really much that we can do, or that Flat Earth can do, to explain how this works. I think that's been, pretty well demonstrated here today. But that's pretty much it. I do appreciate everyone being cordial. It's been nice to talk to you guys without it being a screaming match. And I guess that's it.
Excellent. Thank you. And let's go with Witsit. You've got 60 seconds whenever you want.
Yeah, so I would say for the Southern Star Tribes, you can go look at my most recent Schooling the Globers. I break it all down, and I'm happy to answer questions. Once you actually understand it, either you can just deny it or accept reality. It doesn't physically bend; it's an optical effect. And I would throw this out to all the Globe Earthers that are here. My Schooling the Globers is a new series that I've launched, and you guys can call in to actually discuss the specific topic that is covered then. I think that would be very beneficial for all people, because it seems that majority of people that believe there's a globe don't actually understand what the globe is. And in conclusion, I'll just talk about Occam's razor. I didn't have a chance to throw my input on that, but Occam's razor is that which requires the least amount of assumptions. Okay, it's a logical approach to understanding truth. And in reality, in order to do all engineering projects to build long-distance canals, like in 700 BC when the Chinese built a 1,100-mile canal, you got Suez Canal, Panama Canal. When we fly planes, when we build railroads and long-distance bridges, when we fly helicopters, when we do long-distance radio propagation, everything that we do in the real actual world, we have to treat the Earth as a stationary topographical plane. And then they claim that everything's actually antithetical to that, and we live in a world full of illusions, hence Stubbornly Persistent Illusion by Stephen Hawking. So yeah, Occam's razor debunks the globe.
Okay, we got Dr. Blitz. You're up next. Whenever you want to start.
Yeah, so it's funny that we bring up real world. The flat Earth arguments are often made about simple things, right? We can talk about simple things, and simple ideas can be brought up, and simple things can be argued. But at the end of the day, there are certain things that we see happening in the real world. For example, particle accelerators exist, medical imaging exists, right? All of these things, they rely on certain physical principles that we've demonstrated to be true, and we understand how they work, and that's why we can develop things like medical particle accelerators that can be used to treat cancer. That's why we can work with semiconductors and superconductors to develop high-tech electronics. That's why we can understand and have global positioning devices. So it seems like to me that none of these more complicated points were addressed by my opposition, if only because I don't think that they understand them.
Okay, and we've got Derek. Go ahead.
Yeah, so first of all, thanks everybody. I do appreciate the cordial debate we had here. I want the audience to realize that the observations and all of the different math and things that follow with these observations work on both models. Watching the lights in the sky move does not prove the Earth is a ball. Seeing stars in apparent positions does not prove the Earth is a ball. What it proves is that there's a lot of inconclusive arguments and different proofs that is propagated by the globe earthers to try to propel their model. The truth goes through three stages. First, it is ridiculed. Second, it is violently opposed. Third, it is self-apparent. What this means is the truth is going to be so obvious that all of you are going to realize it based off of your own observations and your own findings. You're not going to need myself or anybody to tell you what to believe. Once you open your eyes and you realize that everything that they have for the globe is not only inconclusive, but it's also built on misconceptions and faulty foundations. They'll take an experiment, and once they fail their experiment, instead of them admitting that they fail it, they change their hypothesis to fit the results of the experiment, and then they pretend as if they're doing sound science. They're
Okay.
not. So I hope everybody by the end of this realizes that the flat Earth is a valid argument.
Globy, you can go ahead whenever you're ready.
Sure. I think flat Earth is born out of misunderstandings of most things in reality, and that's the problem. We have things like calling the lunar lander a tweaker tent. How thrust works in general, they don't understand how thrust works. Even on Earth, they forget space. Thrust in general, Newton's third law. They assume you need pressure or for some reason. Sunsets moving to the right, yet somehow setting to the left relative to the horizon. You know, we don't understand these things. They don't understand these things. The southern stars, right? You don't even understand the problem with the southern stars, right? But you know, hopefully one day we'll educate you guys enough, and you'll come back to the globe side.
All right, I thank everybody for being here. I appreciate you guys coming on and being at least a little bit cordial. But yeah, I'd like to see Dr. Blitz and Austin do something on the side to be good. And yeah, I like debates because at least we're not spitballing as much as we usually do, and we get to see people actually make claims. I thought that today we saw that everybody believes in refraction. Everybody believes that light bends towards the denser medium, but we've got a fundamental disagreement as to whether that makes things appear higher or lower. So it's just, you know, a good thing to take away from this, because if we can design a way to get us on the same page as far as that subject goes, maybe we can start making some groundwork or making some headway. Otherwise, we're just going to keep spinning in circles, and you know how much we like doing that. All right, guys, thanks so much. We'll do it again. That was fun, and we did make some good money for these guys. Thank you guys for everybody who supported. 1,500 people watching. Very cool. And $870. So that'll be split between your two charities. Any final words?
Awesome.
All right, guys.
No, that's great.
Been fun. We'll do it again.
That's really awesome. And again, I just wanted to say, Jaron, thank you. Like I said, I was skeptical at first because I had only heard about you, never seen your content. But again,
all bad things, I'm sure.
You're a really good moderator.
All right, cool. Yeah, and we want to start doing some more of these debates, so look for them. We'll continue doing them. All right, guys, thanks a lot. We will talk to
Thanks for having
you
us on.
soon. Peace.
Later, guys.
Have a good one.
Take care.
Thank you.